Streaming.
All right. Well, welcome and bienvenue to another Neurotech San Francisco Hack Night. Neurotech X is an international community that facilitates the advancement of neurotechnology. Our pillars are community, education, and innovation. We have chapters worldwide, plenty of meetup events, and a thriving online community, over almost 5,500 members on Slack. So check out your local community. If you don't already have a chapter, get in touch with us. We'd love to help you set one up. Also, check out if your college or university already has a student club. If not, be very happy to help you also set one of those up. You can find links to our Slack on the meetup page. Neurotech learn.neurotech.edu.com is the online educational platform. Sign up for the newsletter and check out the job board from NTX services. All right. So, there we go. Yeah, another week. The holidays are upon us. Happy Hanukkah. I don't know if Jaden will be making it this evening, but he will be missed. We did get to, well, we skipped the neurorobotics meeting this week with actually the ignition robotics meeting, community call for anybody who follows that, which is 10 a.m. Is it the third Tuesday this month? Anyway, 10 a.m. You can find the link on the meetup agenda. Also this week, great meeting at Neurotech Paris, where we covered, got to talk with Sylvain again, Sylvain Chevalier, about MOAB, the mother of all BCI benchmarks, and which was a perfect topic for this week with neural PS. And we had our second developer call. First on Jitsi, so we're using the same time for Neurotech X Paris, so 6:30 Paris time, 9:30 a.m. For those of us on the West Coast this morning. And let me just post the HackMD that I can hopefully find. Well, I might need to dig into some old. All right. Well, as we go, I will find that. Also, super interesting today was some great instructions from Flavio Froelich, who's a professor at University of North Carolina, Chapel Hill, who has all the instructions you need to get Muse LSL running on a Raspberry Pi, which is not as easy as you think. And let me. Which what I do want to make sure is that we get that pushed upstream so that they get these wheels built for Muse LSL. And here, let me find the non-LinkedIn blog post here. So anyway, I got to work with one of the UC Davis student club members about getting this running, and so it was nice. It was nice to see these instructions so we can push this up, and yeah. Also this week, let me find. Is the I've let my desktop overtake my ability to find information. Oh yeah. So so Orm joined us from the Neurotech Israel. I think they call them brainstorms, or they're using brainstorm as a name, and brainstorm IL, and he joined us at the Paris evening and had a lot to say. So I guess their lab focuses on sleep EEG, and he's going to be moving here in next summer to join Matt Walker's lab at Berkeley, which is, we've talked about Matt Walker's book, The Why We Sleep. But he's the one who suggested this sleep science podcast and is looking into releasing some data sets that one of which is the SSVEPs that he did in sleeping subjects, which I thought was, anyway. So at the developer meeting today, the Moab developer meeting, since it's kind of focused on adding SSVEP support, we were just talking about this data set and these particular papers. Let me see if I got the. Yeah, here's Orm's paper. Oh, sorry, Orm's paper. So he's checking whether he can release those particular data sets. But would be super interesting for the modeling, since obviously when you're asleep, you have very different active neurotransmitter systems. All right. Let's see what else we got this week. I know I've been just following all the. I mean, there's like next week we'll try and catch up, especially with after talking with Sebastian Trigger at Paris about all the news and events from Neural PS. There's plenty to take in. I know that this state of the art AI site was making a lot of rounds online. Let me just. I mean, there'll be lots to talk about, and we certainly were talking about the work with the work that DeepMind did on the Google X DeepMind did with Project Amber, and that particular pipeline. Still covering those papers in Paris for those that are interested. And yeah, so without John here, I don't know if we can give a bit of an update. The code sprint last week was awesome. We obviously tried to take part in the evening last week, but I think a lot of great PRs, a lot of bugs, not necessarily solved, but certainly properly identified and documented. I think the last remaining problem is really what to do on Mac OS with the Muse. But Hubert Banville has an awesome fix for using Muse with native Bluetooth. So you don't have to use the BLED 112 dongle as a requirement. See what else would John cover here. I know he's still trying to get the IEEE data set, data challenge through IRB. That's pretty exciting. Thinking about that, I don't know if one of the like big tech announcements this week that reminded me of crowdsourced data was the Google Health. Anybody saw this Google Health app? So they're doing a research study with children's, and let's see if I can find the. Yeah, I'm not. I posted this on the Open Humans. Let's see. Here. They've of course got a flashy video, which I'll just post the link. Yeah. So yeah, I mean, Moab, you can now, if you go to Moab's website, sorry, our GitHub, you will see that the wiki has now been enabled. So this is what Devesh got working to this morning, although his very, very late evening. And yeah, you can find, and certainly we're going to open this up to more people. At this point, you still have to be, have basically push privileges to add to the wiki, but this is great. And together with what we've got with Gitter, which is giving us, a lot more. Well, we don't have to worry about Slack messages disappearing. Just let's see what it says. There we go. Yeah, so I've got to find the HackMD though. Let me just see. Because I mean, what would be nice is to be able to share his. Let's go on to Slack. But yeah, still don't have that. There we go. Yeah. So here's the Moab roadmap. The issues that we've got. Let me know if you can access that. If somebody can just check if they can access that. But yeah, this is all part of trying to get the repo cleaned up so that we can do an equivalent code sprint, like just like we did with the E books. So got a PR for MNE. I'm getting in touch with Alexander von Lohmann about the EEG NIRS data set from Berlin that has this weird issue that it has a pop-up menu that you've got to deal with when you want to download it. And yeah, but then you can see some of our more like enhancement and, future directions. The biggest of which is really, can we start supporting, can we support bids? Because all the kind of metadata things that we're trying to add are really just things that bids has already had very, very long, drawn out discussions about. And it will only. Hey, John. Some of the remaining issues, or some of the more recent issues that are definitely relevant, as opposed to some issues that have been around for a couple of years, just because nobody was maintaining. Talking about Moab, I basically relate to things about standardizing data sets and naming conventions and metadata and things like that. And it's just like, we don't want to try and patch, or like, sure, in terms of just making, we want to get past any blocking bugs, but we don't want to try and put band-aids on things that Moab was doing poorly, because it started way before bids. It's just like, support bids, don't try and try and recreate or compete with what is obviously going to have all the momentum in terms of especially this new joint Scott McCaig Russ Poldrack effort called NEMAR, which is going to is probably where we'll be getting our data sets from. Yeah.
I think the thing with bids though is so the main the maybe more than 50%, maybe more than 70% of the benefit of what it provides, having bids compliance, is your raw data files, right? Or not exactly your raw data files, but in the case of MRI data, it's a nat.me and the func.me, right? And that's like half of bids is just like folder names and it's not a nat and func, right? But it's like it's something separated with a couple of dashes that define what it is. But it's that naming convention for the raw data, and then that lets you build pipelines from the raw data. So that's like less relevant if you're not doing like large end-to-end pipelines from raw data, and if you're starting with process data. If you're starting with process data, then the thing that would be relevant is the bids derivatives kind of conventions, which have been developed, but they're not as kind of established or completely followed by everyone as the conventions for the raw data files.
Sure. But it's basically like those are the things that we're going to want to deal with, though. And certainly like the fact that they're not fully fleshed out or concretized yet means that it's a great time to join the discussion and see this is kind of like a question for M&E folks is still like where can Moab fit in, and or like how best it can fit in. Certainly start with there. Start with that, and yeah, like can it also add any value, right? And it's certainly one of the issues that's going to come up is like what how are we storing what has been done to the files, and well, I it's still kind of surprising to me that M&E hasn't dealt with group analysis as much as it, I mean, like for as long as it's been around, how little it's gotten away with ignoring kind of like group analysis and the kind of basically all the stuff that like an EEG lab.study tries to incorporate, like M&E's never has never gone there.
Yeah, you're right. I kind of sometimes I'm a bit disappointed by that. There's not so much of, well, there's like end-to-end pipelines, but it's not as part of the package. So the other comparison like SPM, right? So SPMs, they have their own way of naming things, but you know what the first level analysis is, you know what the second level analysis is, and it's fully expected that you're going to have a design matrix for your second level analysis.
Yeah.
And you know what the inputs are going to be, and that's like if you've only done the analysis up to the first level, like whatever you're doing to the individual subjects, then that's only half the job.
Yeah.
Yeah.
But let's hope that we have a better system than like ADF, CA, or like in terms of what has been done to a file.
So what are you aiming for with Moab in terms of provenance information? I mean, are you trying to capture everything?
Yeah, I mean, it's without subjecting everybody to the nitty gritty details of what we were covering, but there's like one super relevant, like somebody made a contribution. I mean, the main point was like people are making contributions, and there's like with EEG or EEG notebooks until you came along, like there wasn't anybody necessarily merging those and kind of managing that, and yeah, so this person who made a contribution is also like wants to donate a data set or wants to add a new data set, but it's also it doesn't fit into the existing provenance, or and it's not just provenance, but like how they wanted to structure class trial types, I guess, and again, like the kinds of things that like the study object, had dealt with, or, like EEG lab, where you were doing your whole thing in EEG lab and, saving everything in that one structure, or at least, data structure. And like, the question was, or certainly, in the thread on the issue, it was like, should, can we change this? And it's like, absolutely we can, but that should be just to keep us going, and not, like we should have a real design discussion about how to better incorporate what's going on in the community, like BIDS EEG, right? Which again, like right, might have some issues, because like you're saying, like certainly Moab's not trying to be a pre-processing is trying to ignore all that.
Yeah, that's the thing. That's the thing when you're going in at that, when you're not going from the raw file level, is you want to know, right? You want to have some kind of metadata,
Right.
but and that may include even parameters of analysis pipelines, but not every single detail. Like that's so you want to be able to abstract. You want to know what you need to say and what you kind of take as read.
I mean, if you have a chance, it'd be awesome to get your feedback on some of these, and I mean, yeah, and also just how we can do the GitHub pages, or to add to neurotech.github.io / in this case Moab.
Oh, you mean you do a Sphinx gallery
Yeah.
docs, right?
Yeah.
Yeah, that's something that's something to definitely think about, because I think so that there's actually a video that was, I think it was on the Nylon Developer Days thing that was earlier this year.
Yeah.
And it's called Documentation Driven Development.
Okay.
And that's part of the idea, right? So you kind of organize the library to some extent around having the Sphinx gallery auto building all of your examples, and that in and of itself is a type of CI, right? Because if any of your examples break, then you know that some change you've introduced is, but it also, but what it leads to is like your code development process. It kind of goes through the documentation as a natural, part of the route, rather than the documentation being something that you do post hoc off on the side, and insufficiently. Right. So from that point of view, and I think that the message we'll be getting when we talk to Alexandre next week is going to be that, like, getting this in place is a critical like just first step for these, like a modern open source scientific project, is getting the documentation driven development down and the CI components of that. And then once you have that, then you start building the rest of it.
Yeah. I mean, I'm just looking at these, like the set of talks from this. It's like, yeah, all super relevant. And luckily all available.
So how many people are working on Moab now, and what's the developer base?
Well, so like definitely Sylvain, Devesh, and Rashik.
Rashik, who joins these calls?
He has, yeah.
Okay.
So like I mean, Devesh was able to join this morning, or his super late evening, but they're both. Sorry, I got asked for ice cream. Everybody's doing finals right now, right? So that's what, like, so Rasha wasn't able to join this morning. He joined last week, and yeah, but it was great. We got like Devesh and I got added as admins, and at least we can add to the wiki now. It helps with just a little bit of the organizing that we're doing. Like, it definitely needs more. Like, it wasn't it was never kind of like fully released, or it was still considered a development.
Hey, John.
Hi, John. I'm just reading your notes right now.
Do you think I've actually never heard of Sphinx Gallery? Do you think like maybe after you guys talk about the Moab update stuff, you guys could give us an example of like
Oh yeah,
a
absolutely.
Sphinx Gallery you'd like to see? Like I actually didn't realize that was a thing. I guess it's been a while since I looked at like scientific documentation
Well, it's
and just Googled
specifically
it.
specifically this like Python neuroimaging community. I know that one of the guys, his GitHub name is Larsoner. I think his name's Larson, but I'm not sure what his
Eric Larson.
is. Eric Larson. Yeah,
Yeah.
he's he's one of the M&E core contributors, and he's one of the Sphinx, or at least the Sphinx Gallery core contributors as well. So I think maybe it's kind of gone in early in this specific community, and it might not be like as you know completely widespread, but it's definitely got a foothold. And yeah, let's carry on. Let's finish up with Moab, and then I'll do exactly that. I'll go through some things.
Yeah, I mean, but another great example of basically a bunch of neuroimaging people being core contributors to computational and scientific Python. or yeah.
The main one being scikit-learn.
Scikit-learn, right, yeah, and yeah, I'm just looking over all this.
I mean, there's Gael Varroquois and Alex Granfort, and they're both like major scikit-learn contributors. There's probably more, but
yeah,
there's a mafia of scientific Python people also doing neuroimaging, which is nice.
Yeah, this is why it's nice that Sebastian joins us. The Paris Hack Night is that they all kind of went to school together. It's that's what he's told me. Yeah, so
like university or high school?
University.
University.
I think university. Yeah.
I'd be like an OG, like Red Hot Chili Peppers kind of thing.
Right.
To high school, yeah.
Hey, it's been a while. We don't have you're muted.
Hey,
Hey.
can you hear me now?
Yes.
Perfect. Yep. The semester just finished, and I'm
Sure.
amazed and sleeping. I'm so excited now. Looking good, John.
Oh, thanks. Thanks.
Yeah.
I still haven't had a haircut in almost a year now, but I have started back.
Is that what you've been doing? You've just been doing the whole pandemic no cut?
Yeah. It's as long as I can kind of maintain it before my wife literally comes in with a pair of scissors, but hasn't done it yet.
The facial hair is looking good, though. You like scissors for those? For your mustache?
Yeah, that started out in a similar vein. Was like, okay, this would be amusing, and then I thought, oh, actually, why don't I just tidy it up and do a thing.
Mm-hmm.
It's a bit unsure. Tricky thing is like getting them to go in the right direction, because like this one, it always wants to go down there. So I have this like my natural mustache shape is definitely a sigmoid.
Well, that seems very on brand.
Right.
That it should be
a lip integral.
Yeah.
Right. Okay, I should embrace it. You're right. Okay, I'll think about that. You're also looking good, and I think it's the first time I've seen you without an EG on your head.
Oh, for now, apparently next month, Muse is gonna come out with a big sleep update where they'll like track the sleep stages for like in the app. Very excited.
Oh, you know what? I didn't check in with So I see Josh Phipps joined us. You did get running from last week, yeah, with the.
I did. Yeah, I got everything up and running, and The only problem is I can't figure out where my files are going.
Okay.
And to be honest, I had a release this week, so I literally just finished about 2 hours ago. So I've
Okay.
had about 2 hours of sleep all the week. So I'll look at it again. I'm sure I'll figure it out. It's probably something dumb.
It's in a hidden folder. It just depends on what your user what's
profile.
your
That was I'll sort it out. But yeah, it's really weird. Like I just ran Blue Muse like I don't know like a dozen times, and all of a sudden it just stabilized and it works fine now. I have no idea. I didn't change anything. I didn't touch anything. It just decided to work. So I'm cool. Yeah. So I'm very excited.
Sure.
So,
computer software.
Yeah. Exactly. Yeah. I didn't even do the Microsoft thing, or I didn't even reboot. I just it just worked. I don't know. It's some of the oddities of life. So
well, I was kind of hoping that Pega would join us again because we never got her running.
Yeah.
And yet I could recreate her problem on Win 10 and could solve it with this particular command, which I posted at least in the Mattermost, which was like turning off the security, that was causing her to, causing the app to not basically execute.
Right. Untrusted app or something like that, right?
Yeah. I got in touch with the Blue Muse developer who could not recreate this problem.
Oh, great. Those are always the fun ones, right? Yeah. I had the same problem, but then, like I said, I went through the manual steps, and then I went back, and that didn't fully work. But then once I loaded the cert, when I went back to do the automated load, it worked fine because I think the cert overrode the security issues or whatever. I probably ran some other commands I don't.
Well, I mean, again, I would love. I know I've got to unbox a small PC that, even though I'm going to wipe it, it'll come with Windows, and so I'm going to just use the Windows that came with it to test this, fresh, and I've got this one-liner that solves it.
Put it out there. Yeah, put it up in the instructions or something. So I'm imagining other people probably run into or get them to put it up there somewhere because it seems like it would happen all the time unless you've highly altered your rights management in your Windows construct. I think everyone would probably run into it. Seemed like pretty.
Yeah, well, that's
thing.
Because Jason's response was like, oh well, if you're not admin, I'm not sure what would happen. And I was like, right. No, like these people are admin.
They own their own boxes. Yeah, it's not.
Yeah, well, like they're the only, they're sole users. Like you can go to. I mean, this is the thing. Like I could recreate it where I went to command terminal, run as admin, right. And it would give me that message.
Right.
Until I use this. I'll find it.
So next, I'm going to try and tackle my insight with Scikit. That'll be my next beating my head.
Okay.
I'll get it over Christmas when I have less things to deal with. So.
Okay. Well, I like that plan.
Yeah.
There are other people who can.
Because I think people are using epochs with that, right? So I'm hoping that it's not too far off. They must use the same sorts of protocols. I'm imagining, just more channels, right? And then the last one is getting the Mayo to work. That's that one. I don't have any idea how to do that, but I'll figure that out.
Yeah. I
got it working back to my Raspberry Pi because that's how we did our demo before. We had a Raspberry Pi that sat between the Mayo and the Google Glass. So the Mayo would read you're doing a handshake, tell the Pi that was happening, and then the Pi would then tell the Google Glass to take the picture of the person you're shaking the hands with. So we had to put a Pi in the middle, but I'm sure there's better ways now. That was a while ago. That was hacky at best, but it works,
Hey Morgan, just to briefly touch on the whole BlueMuse cert installation thing.
Yeah.
From installing it on a couple of systems, what I've been able to guess is that the release that you're using determines the defaults that Windows will configure with. So if you have Home, it sends the defaults to like the non-permissive ones, so you won't be able to install on Windows 10 Home without doing the extra step. On Pro or in an Enterprise one, I think it's a lot more dependent on what you're going to run. So you could potentially install it on a Pro system and it would have all the permissions and just be good to go, and then try it on Home and it would barf. So there's something very specific with PowerShell permissions and adding certificates. And the reason that this whole rigmarole was done is that Windows was originally pushing UWP as Windows Store only, so it runs in a walled environment, and you can't get the data out of UWP processes into system memory. So he had to install like a custom cert, and like he runs this other process that he pipes the data to from inter-process communications to escape the walled garden. It's actually pretty elaborate how much stuff he had to do to get that data.
Yeah, that was my suspicion too.
Right.
And that came up, or at least that like Home Pro distinction, because I made my son, I'm making my son go through software carpentry, but do it like he had to install Windows Subsystem for Linux, and then run through software carpentry, and it was great because he was like, "No, you can't do it." I'm like, "What do you mean?" He's like, "Microsoft says you can't install this," and I was like, "Okay, first lesson." Like ignore everything that Microsoft itself.
Pretty much it, right? If they say no, it means yes.
It means you haven't done enough work to figure out how to circumvent that.
You're going to discover what the government discovered. Something called parallel construction. Sorry. Go ahead.
Well, it's funny because it's like I then read the instruction that he read, and he hadn't understood it, and it was like you still have to do like Windows Insider program and
the most important part.
Yeah, and like install a dev version. Like you've got to upgrade your Windows.
Yeah, it's a two-step process. When you launch PowerShell, you have to make sure it's in admin mode. And then the other one is just like you were saying, right? There's that, there's like a system setting for regular, allow sideload, or developer mode. It's like a 3 radial button thing. And either sideload or developer will work, but regular won't. So you have to like change the OS setting.
Yeah. Well, so I would like, or, like John and I talked about this, like, if we're gonna roll this out to a bunch of people, right? Like this is going to come up so much.
It's going to be the main thing.
Yeah, and I mean, you could even have that command as a fallback. Like, you should expect to run this if the auto installer fails or something. But everything works smoothly once you get past the cert and the installation. So the good news is, as far as I've seen, that's the only pain point. I will offer one more thing, which is about every 2 weeks or so, Windows will periodically forget the pairing in this really weird, confusing state. You have to unpair and repair the device in Windows. You might want to make a mention of that as well.
Still a 2-week window then.
I have a kind of rather, I think, unique experience, or at least I haven't heard anyone else have this, which is, so one of the machines that I run BlueMuse on is a work machine that I have admin access on, as I kind of got them to give me, but I know I'm not like the Uber admin on it. It's some kind of graded level of admin access that I don't fully understand, but I can install things. In any case, with BlueMuse, I have to reinstall it constantly. So I'll run the installer, and then it'll turn on like from the icon, and it'll stream fine. But if I come back a few hours later, maybe I restart the machine, or maybe I don't. Maybe I just do some other stuff, and I click on the icon again. It won't start. It'll kind of maybe it'll come up and then it'll just get closed down, and it looks very much like a firewall type thing. But whatever it is, I need to rerun the installer. So So my my kind of usual Bluemuse usage is rerunning the installer multiple times over several hours. Unfortunately, it's quick enough that that's not a big deal. It's like 30 seconds. But I would like to know what I need to do for that not to be the case, but I don't know yet.
Yeah, you might have like a group sorry, go ahead, Morgan.
Well, I mean,
Yeah.
I had to learn about group policies,
Right.
and I would definitely like try in your PowerShell some of these like info dumps that kind of like see how your system is configured, because certainly if it's a work system, yeah, they're doing some policy setting, across all installs.
Yeah. Like in the InfoSec space, we dealt with people that would lock down their systems a lot, and there's various ways you can do it. But what it sounds like is like you can install user apps, on your local profile on the system when you're logged in. But there's probably some limitation on the ability to make like OS level changes, in the C Windows or the INIs or the registry or whatever.
Is it somehow like every time he's getting a Windows update, is it locking him out? No, it's not.
No, it's much quicker than that. It's basically, it's more or less have to reinstall it every time I want to run it.
Oh, right.
Right.
We can create a little batch file for that. You can run installer and then open. Okay, here we go. It's magic.
Yeah. I mean,
it sounds like it'd be easier.
But I'm doing, I'm kind of like, I've got another terminal. I'm like, activating the Conda environment. So it's
doing real work, waiting for Windows to catch up, right?
Yeah. It's not something that I've felt inclined to put my kind of intellectual energies into as yet, but it is kind of awkward.
Well, we're gonna come back to this, and part of why we're gonna come back to this is that Mike actually has some muses. Am I correct? You've got two, right?
I found a third one.
Even better.
Just laying around.
I do. Yes.
Okay. So, and are these different models, or like?
It's they're all the first two generations. So not the Muse S.
Right.
But yeah, the one that
2016.
That's right. Yeah, I think two are 2016 and one is, what did they have, 2018? Or is 2016 even Gen 2?
Yeah, there's a 2014,
I think there is older, but...
Yeah, there's a 2014 Rev, a 2016 Rev, a Muse 2, and then the Muse S.
When did Muse 2 come out? At the same time as Muse S?
Yeah, about a year and a half ago, I want to say.
Okay, yeah. So, yeah, I might have the 14, 16, and Muse 2. I don't remember. So I bought one when I was back in college, which was definitely the 2014. And then we had the CEO at my company is friends with Ariel at Muse, and so she sometimes drops off some for us to play with.
All right. Well, let's get you started, but yeah, I'd love to have you as a user, an EG Notebooks user as well, and so we'll put a pin in this and come back. So I want to introduce Mike, who's our speaker presenter today, coming at us, a scientist at Neosensory. And do you want to give us a little bit about your background and what you're doing at Neosensory, and then take it away?
Yeah, sure. So thanks for the intro. My name's Mike. I have a background in undergrad in neuroscience from the University of Maryland. Graduated 2015, and then right out of college, jumped on board at Neosensory. So it's about 5.5 years ago. And I joined as a scientist. But I joined when there were just three of us. I'll talk about what we do as a company in a second. But I joined when there were three of us, and if anyone is familiar with the world of startups, it doesn't matter what your title is, you do a little bit of everything. Now there's 20 of us, so maybe I'm a little bit more focused, but certainly had a lot of fingers in a lot of pies over the last 5 years, which has been great. It's been a joy. But yeah, I'll share my screen and show some slides just to help me talk about a quick backstory of Neosensory, So let's see if I can do this right. Share screen down here.
Oh, yeah. Are you?
Does this work? Is that how I should
That's
do it?
perfect. Yep.
Awesome, cool. Let's see, you can't see me at the same time. Is that right?
It's how
fine.
do I solve this?
It's
no.
It's not.
You know what I found is if you, it's a weird thing. If you play a video, if you play a YouTube video, then they'll make a little small screen of you in the corner, which you can leave the video up, and then your little thumbnail will stay, or at least. But if you don't mind, this is perfect.
Cool. I don't mind. Yeah, I have a wristband here, and so just in case I need to give you all a closer look at the wristband, I can turn back my video. But cool. So yeah, I'll just show a couple slides. So I'm going to talk about the dev tools that we have because we really want to make this something that people can play around with and control. But let me tell you first what we do so that you have an idea. So Neosensory started 5.5 years ago as a company, but before that, it was a PhD project between these two. So David Eagleman is a professor now at Stanford, although he was originally in Texas at Baylor, and his student Scott was working with him on this idea of sensory substitution. And if you want the full science behind that, David gave a pretty good TED Talk, I think, back in 2015. That goes through a lot of the history and a lot of the neuroscience behind sensory substitution. But I'll just, I stole some screen grabs from his TED Talk so that you don't want to listen to it for 20 minutes. I'll just give you the quick talking points. So the background, the idea behind sensory substitution is, okay, we've got our 5 or 6 or 7 senses, depending on how you count, as humans. Animals, though, are not constrained to those. There's nothing that says, hey, you have to have these specific senses. As an animal in this world, bats, feel air compression waves, and they sense that. Our understanding is they sense that as location or objects in front of them. Ghost fish detect electrical fields. Ticks detect heat and body odor to a much greater precision than we might be able to. And that's how they get around and find where humans are and where to go. And so one of the questions you have to ask is, what is it like for them? And also, can we add some of these senses to our own repertoire? Like, is there anything stopping us from being able to gain those senses? Maybe we don't have the biology to feel electrical fields, but we can build technology that does. And can we somehow input the information from that into our brains? And taking a step back, if a human loses a sense or is born without a sense, and if they want to be able to regain that sense, can we also connect to their brains and hook up some of the information that they're missing? And so in his TED Talk, David talks about cochlear implants and retinal implants. And so a couple of weeks ago, we had a great talk from someone, I'm forgetting his name.
Joe Crew.
That's right. Thank you, Joker. So he talked a lot about his work with cochlear implants, which is very good. So you might have seen that. But the idea here is basically both for cochlear implants and retinal implants. Okay, your cochlea or your retina, whatever nerves are leading from the outside world into your brain, they're not giving your brain the right information. So let's hook up an electrode so that we can zap those nerves, those neurons with different electrical impulses. And back when people were first starting to work on this, cochlear implants are a little bit earlier than retinal implants. They weren't really sure if it would work because all you're doing is putting a wire into your ear and zapping your neurons, and maybe your brain will understand it, but it was kind of a big, Hail Mary almost. And sure enough, it works just fine. It's not as high resolution as hearing, but your brain figures out how to understand these different electrical impulses. And one of the interesting things is because of how the cochlea, that part in the inner ear that detects and responds to different sound waves, because of how that's constructed, it's hard to get the wire all the way into the tip of it, and so you can't really ping the neurons that are normally responsible for low frequencies, for like the low tones. But what you do is you just use the information that would be stimulating those low tones and stimulate it at a different part of the cochlea. And so you just shift everything up a little bit, and the person's brain starts to realize, oh, you know what? I can shift all of this. I can start paying attention to that part that used to be 400 hertz, and now I know it's 200 hertz. And so it's really cool finding that yeah, you don't need to hit the exact neuron that means 200 hertz. Your brain will learn to adjust and to take the 400 hertz neuron and the 800 and shift that all down. So it's not mind-blowing, but definitely an interesting thing. But it certainly leads to the question, well, how far can you shift this? How good is your brain at starting to understand different inputs? So instead of putting a 200 hertz sound signal at the 400 hertz neuron, can you put visual information into the neurons that are attached to your skin on your back? So back in the late 60s, this guy, Paul Bacchi-Rita, started playing around with this idea. This is the very beginning of sensory substitution, which is an umbrella term to talk about feeding in sensory information to your body through atypical sensory pathways. So what he did, instead of making a retinal implant, which is an invasive surgery, he took blind people, and had them sit in a dentist's chair with a bunch of vibrating motors embedded onto the chair to tingle their back. And then he had them sit in front of a video camera they could control, and they could turn around, and the pixels recorded by the video camera were transmitted to the dentist chair, which then vibrated specifically in whatever the pixels were recording. So if there's a bright white pixel, the vibration is very strong. And if there's a black pixel, it's not. So what you're doing is you're taking the information a video camera or your eyes would detect and just playing that information onto your back. And what he found was, yeah, people's brains were able to really well interpret this information. And not only were they able to say, oh yeah, I can like kind of feel this tracing of a, what is that, a mug on my back? I think you must have put a mug in front of the camera. But they actually start to say, after using this for a while, you know what? I feel like I'm seeing a mug, or at least I feel like there is a mug in front of me. So it's not this conscious thought process, but instead just an unconscious way to just how you or I might say, yeah, there's a mug in front of us. So that was a really cool finding. He ended up going forward with this as a company called Brainport, actually called Wick Labs, but they made something called Brainport, which maybe you've heard of before, and it's a little array of electrodes that sits on the tongue. It's much smaller than a dentist chair, of course, and the tongue has a lot of different receptors, so you can still play a lot of high-resolution information through the tongue. So that's cool. Unfortunately, you have to take it out if you want to eat or talk, so there are some downsides there. And that's where we came in. So we decided to try to test this idea out with a vest. So he was using a dentist chair in the late 60s. We have a big advantage of much better technology now. And so instead of having to have something in your tongue, can you wear this on your torso in this vest form? So we played around with this for a while, and what we were doing, instead of for people who were blind, what we were focusing on was people who were deaf and hard of hearing. So could we have each one of those motors represent a slice of frequency, just like the electrodes that go into your cochlea and a cochlear implant do? Can we have each one represent a different frequency and teach your brain to understand the signals coming from those nerves as frequencies and understand different patterns of those frequencies as words or different sounds, which is exactly what it does with the information coming from your cochlea. It doesn't know, at some point in the brain, it doesn't know, there's no tag saying, hey, this is information coming from the cochlea. It just knows this is sensory information about sound. So there shouldn't be any reason why we can't just feed in that information through skin on the torso. That said, of course, it's a lot lower resolution. So we did this for a while, and we got to the point where this is one of my coworkers. So he's deaf. He was the fourth employee, I don't think, I'm going to mute this because I can hear it, but you can't, and you don't have to. Scott there on the right is saying, hey, pick 4 new words. So Jonathan on the left, the deaf coworker of mine, writes out 4 new words. Let's just go ahead and do playback speed of 2. Y'all can see this video fine? Good,
Yes.
thumbs up. See it. Awesome. So Scott's saying, great, go ahead and pick 4 words. So Jonathan writes play, and then Scott reads out the word play and work. And so Jonathan is learning in just these 30 seconds what those different words feel like, just by a couple of different instances each. And then Jonathan says he's ready. Let's see. Still training. Oops, sorry, didn't mean to skip that slide. After a little bit of training, so Scott covers his mouth and says one of the words, and Jonathan thinks about it. How's that feel? And points to it, and he gets it right. And Scott does it again, and he gets it right. And so what this is showing is that Jonathan, after wearing the vest for a few months at this point, although we can also do this with people who didn't wear it for that long. After wearing it for this long, he's able to learn up new words very quickly. However, he does have to think about them consciously. So ideally, this would get to the point where he's not thinking, okay, that pattern was play. He got better at it. He's a lot quicker than somebody who first starts wearing it. But I do want to point out the caveat that he is still thinking consciously about what these words are. So he's very excited about it. What he was most excited about, though, when he was wearing the vest wasn't like, oh, yeah, I think maybe Mike said sleep or work or play. But instead, oh, wow, somebody just walked into the office. He happened to sit, he liked his seat where he couldn't see the doorway into the office. But he would know, hey, somebody just knocked on the door, somebody walked in. And it was just a good tool for him because otherwise he wasn't able to know that. We realized we could create that a technology that would meet that demand with just 4 vibrating motors in the form of a wristband, which is a lot more comfortable than having to put on a whole vest. And so after a lot of user research, we found out, hey, a lot of people in the deaf community don't care so much about speech. What they really want to know is information about the environment around them. They want to know, is a siren going down? Is somebody yelling my name, etc. So we ended up selling this as a wristband instead. And we launched that this January, right before the shutdown, unfortunately. But we've still been met with a lot of good feedback from people. People are very excited about it in the deaf and hard of hearing communities, which is great. So we are continuing on with that. But we also do have a big desire to work with developers. We all are developers and hobbyists. This is not something that, frankly, our VCs think is a great idea because it's not going to make us a ton of money. It's not going to make them a ton of money. But we are all nerds who love this stuff, and we wouldn't, it's not too hard for us to at least open up things a little bit so that hobbyists or academics or whoever can test with this wristband through a number of different SDKs. So we're still working on that, and I'll talk about that now. But any questions so far about what we've done at Neosensory? Cool.
No, I think we're good.
Cool. So, yeah, just anyone feel free to jump in, interrupt with any questions. But that is the backstory for the technology we are working on. So first, let me just put this out there before I forget. There is a Slack channel, a pretty active Slack channel. So I can share that afterwards if anyone's interested, or you can just, you should be able to search for it, or at least it's at the bottom of all of our developer posts on our blog. But if you are ever working with this or want to ask people who have worked with this any questions, feel free to jump on that Slack. We're on there every day. And so there's 2 SDKs that we've built, an Arduino and an Android SDK. and there's also an iOS SDK that was made by a community member. So you can find that. I can share that, or it's you can join our Slack channel. But it's Chris Bartley's Buzz BLE repo. So if you want to do something in iOS instead of Android, he has made a Swift package. But that's not officially ours. But he graciously did that. So all of these SDKs, though, if they don't give you what you want, you can get around it, because all you need is to be able to connect to the Bluetooth, and you can go dissect any of the libraries we've made and just see, like, okay, like, I just have to connect to Bluetooth. Here's the name of the device or the naming convention of the device, so I can find it, and then here are all the different commands that I have to send. So either over Bluetooth or over USB. Unfortunately, the USB port is on the bottom of the device, so you can't wear it and have it plugged into USB. But at least for development, you can plug in over USB and still feel the motors with your fingers. Once you're connected via USB or Bluetooth, there's a whole bunch of commands, getting getting information about the device, getting battery level, etc. But mostly what you want is to be able to control the motors. And so, like I said, there's 4 different motors on the device, and you can address each one of them at 16 millisecond intervals and at an 8-bit resolution of intensity, so 0 to 255 intensities. And you can turn on all of them or just one of them. And yeah, so these SDKs let you hook up any sensor or get any information from online, and through whatever method you want, whether it's Arduino, Android, iOS, or some other Bluetooth thing that we haven't implemented, you can talk to these. So, for instance, I've worked in Unity to make a couple different games that use this, and I haven't had time to put that out there and make it public, the library I've used to in Unity to communicate with this, but you can easily recreate it, or just contact me and I'll figure out how to pull some of the code out and share it with you. Before I move on, I do want to talk about this real quick, which is just a contest we're doing with Edge Impulse. So Edge Impulse is a really cool company making it easy to do machine learning and neural networks on edge devices. So if you have one of their boards, you can do some really cool machine learning stuff and kind of hook that up with our Buzz and talk to the motors on Buzz, the wristband. So the contest, you don't have to use Edge Impulse's stuff, but you can if you want. There are 2 phases to this, and unfortunately one of them has already passed. So one of those phases was just, hey, send us any idea you have. We'll pick 10 of those and send free wristbands to those people. However, the second phase, which is still open, is actually making some of these applications, and that's where the money prizes come in. So if you, the phase to get the free wristband has already closed, but if you want to still participate in the second phase, you can buy a wristband from us and then still enter your application into the second phase, and you might get some money out of that. So there's a lot more details about all of the breakdown of the money and the goals of the contest, but the general goal is to create a new sense through the wristband. So yeah, now I just want to open up to any chat, any conversation about how to use these SDKs, what you all want to see out of the SDKs, what you think you might want to make, what questions you have about making it, or any conversation at all. But that's all I've got here.
Yeah, I mean, I just I'll find the page, or we can add it to the chat, but like the number, like we talked, because you were at the hack night like the night before the first phase, because it was like November 20th, I think.
Something like that, yeah.
And yeah, so because I certainly brought up the contest, and and you got like 90 plus submissions or something, right?
Yeah,
Like,
we got a whole lot of submissions.
I mean, and you know the page of so I mean I put a lot of these links in the meetup agenda, you know, and but so many cool things, or you know, like lots of ideas. But yeah, I think like as John asked, you know, like the first thing I wanted to do with it, or you know, was basically use it as a stimulation device. You know, but be recording EEG and use it as a stimulation device. And you know, I was talking to Devesh about the history of Field Trip, which is a kind of well known MATLAB toolbox for EEG source imaging, and you know, and Robert Oostenvald developed it as an open source version of something called dynamic imaging of coherent sources. And what that was for was or what Joachim Gross, who's the original author, did was he was looking at Parkinson's patients, and so they had a tremor, you know, and so what he was doing was basically like using EMG to and a little bit of signal processing just to get what their tremor frequency was, and then was like, oh, okay, now in the MEG, I'm going to look. I mean, I'm gonna, in his particular paper, he's like, I'm gonna seed voxels in motor cortex, and I'm gonna look for, you know, coherent sources, or you know, basically coherent time series at this, you know, in this kind of frequency band. And he, you know, pulled out these cool maps that, you know, was like, God, I think it was like 2000. It's scary to think that was 20 years ago.
Yeah.
You know, so like, but here's you know, here's a cool thing, right? Is that you can be wearing an EEG, especially, you know, some of these mobile headsets. Although, you know, maybe not Muse is not so well situated, but say Neurosity, you know, or any of the devices that can be up here, and you know, and it's a cool graded stimulation device that can do frequency. You know, basically I can get a nice frequency response. I mean, I can generate a nice frequency response that I can then go find in motor cortex, and yeah, I mean, you know, like it will. There'll be I mean, it's all right here, so this is all going to be very close together in terms of where those sources are, but the real thing is the 8-bit control of the 4. Right.
Yeah.
Is that you can, you know, you can really vary that. You can look at, yeah, I mean, anyway.
I would agree. Like, speaking, part of your question was like, what do you think the developer interest would be? And at least like in terms of the EEG scientific community, there's a big chunk of the, you know, EEG researchers they just work on somatosensory and motor system because it's simple and it's the thing we understand the best. And if you're like, you want to measure an EEG and know what it is, you tap the fucking wrist, right? That's the only thing we really know, or that's one of the things we know the best. And it's definitely, and it's used for people who want to like calibrate, you know, scanners and devices and have like really robust paradigms. So there's a huge chunk of scientific expertise that's all based around, as Morgan was saying, like somatosensory stimulation. I'm sure you're aware of this. Right?
I'm sure. Yeah.
That definitely springs to mind.
Yeah, I actually, I mean, I'm super excited about, you know, working with these EEG devices. But I've largely only thought about it in terms of representing some of the EEG signal to you, so that like maybe you can start to learn, like, oh wow, like yeah, my alpha I'm feeling my alpha bands are really high right now, before I realized that I was like getting sleepy, things like that. But I haven't I didn't know too much about the research of tapping on the wrist to be able to calibrate the EEG on that.
Yeah,
so
like,
what do you see? You see like an ERP or you
yeah,
see a shift in
yeah,
frequencies?
it's an ERP. It's the somatosensory evoked potential. Like it's like a visual evoked response, but in the somatosensory cortex. And
Mhm.
yeah, especially if you look to kind of methodsy EEG and MEG researchers, that's like the paradigm of choice. People who are like exploring new source localization metrics, or sometimes if they have some other kind of new technology they're exploring, like sometimes if it's like a pharmacological intervention, or brain stimulation as well, so this kind of thing that if you're looking for some kind of basic physiological response in the central nervous system, then the somatosensory evoked potential is like the primary thing to look at. So it's both, I would say it's both like people who, or maybe three general groups. One is methodologists who are interested in the like signal processing and just like ways of that they really care about improving non-invasive brain measurements, and so they use a simple paradigm for that reason. There's people who are more clinically oriented, and they have some intervention that they also want a kind of simple CNS, biomarker index, right? So again, like it's a simple physiological response, so it kind of comes in there. And then the third one is people who actually study that part of the brain in and of itself, like who aren't necessarily methodologists, but they're neurophysiologists, or often I would say like people who study the motor system also. There's a kind of a pairing between somatosensory and motor, so sometimes they're kind of motor system oriented people. Yeah, those would be the three types of people I would expect to be kind of interested in that purely for improving their workflows, or things that they can do for the applications I already have specifically for SSVPs and SSEPs.
Yeah.
Yeah.
It's also nice where the cortex is right under here, like the generators are right under here, and I remember it was Richard Greenblatt saying, like, if he could have one thing, it would just be a really nice somatosensory stimulation, and an MEG. He did say and an MEG, but because like you can do the same reason that kind of like visual people use this area right here, and and lots of retinotopic mapping, and playing out across that limited region, but you can do the same thing, and again, like it's just nice how, or like again, like the you package like the perfect simulators for people to do some really fine control of this.
I would say as well as so it's not just EEG. I mean, and MEG. So like in the case of particularly like MEG, because the kind of people who really care about spatial localization with MEG, as I said, they often do a lot of work in somatosensory cortex and motor cortex. So if you often have like some interesting paradigms that are trying to differentiate parts of the wrist, or wherever it is that you can kind of get the somatotopic mapping within the somatosensory cortex, right? So, but the other thing is neuroimaging. Okay, so the people who were actually studying things like the stuff that I guess David works on, or at least he's interested.
Mhm.
It's like this, sensory remapping stuff. But so like sitting in an MRI scanner, but actually having some funky stuff going on your wrist, and actually like looking at what's going on in some sensory cortex was a kind of interesting new paradigm.
Yeah, yeah, yeah. We're very interested in doing some of that stuff. Yeah, this version of the wristband will have issues near an fMRI. MEG would be fine, but we'd have to play around with some way to stimulate the wrist. I mean, yeah, these motors actually use magnets, in fact. So even if you got rid of a lot of the stuff, the motors themselves use magnets. So some hurdles there for fMRI, but with MEG, yeah, you might be able to see some of the stuff going on.
So sometimes, yeah, that's one of the reasons why people will attach it to the feet.
Right.
The feet are kind of sticking out.
Yeah.
It depends. Yeah, I totally understand. And so Dave McGonigal is the person I referenced here, just because these were very much kind of paradigms that he was using at when he was at UCSF in both MEG and fMRI.
Mm-hmm. Okay, cool.
He's now in Cardiff, and I haven't gotten in touch with him yet, but I do want to. He'd be like the person that I would talk to in terms of what would the the kind of the current packaging be kind of ideal for, in the sense of like just working with the wristband, and as well as like John mentioned, a lot of TMS has actually really focused on looking at median nerve stimulation, and so much people are doing they're using this kind of like known input. Dave would also have a lot to say about like doing TES of motor cortex, and what your expectations would be given this nice stimulation that, again, because it gives us a steady state response. It gives us a nice it'll be a nice response to pull out and to kind of look at its modulation. Mm-hmm. And yeah, so maybe not what maybe not what your funders are looking for from us, but I still think it's super interesting, and I still think that it some of the things that, or the first thing I want to know is how can we get good timing control of it? So
yeah, because that's really critical for this, right? Like we're doing with the Muse, we're doing these visual paradigms where there are components that are expected at 200 milliseconds, and we have this kind of 30 millisecond lag, and we're not very happy about that. But it's 200 milliseconds. But if you're talking about a motor system, right? I mean, that's like sub 50 millisecond latencies for in a lot of cases, right? So I guess the lag becomes particularly critical if that's something that you want to facilitate.
Yeah. At that degree, the latency is something that you have to consider. The motors can turn on to half of their full intensity in 16 milliseconds. But half of the intensity is still pretty strong. So if you only need to turn them on to that 16, you need to turn them on full intensity. It's a little bit longer, but not much. So getting them up to speed, will add a couple dozen milliseconds, which might be too much or might not. And then otherwise the system, I mean, especially, I guess, the Bluetooth latency adds a little bit there, but not so much. So we do, because your brain wants this information very, very quickly as well for new senses, for sensory substitution applications. We've worked hard to get the latency very, very low. But there's only so low you can go.
Oh, I'm sure it's not a problem. It's just us knowing. Yeah, I'm just looking at the Arduino SDK. Or I mean, I think what we need is basically an LSL connector, right? I mean, I think that would be the
sorry, what remind me what LSL
lab streaming, like lab streaming layer. So the great thing is that, like, you know, this is essentially what lab streaming layer was created for. You know, in that the most common devices that require kind of like network time synchronization are basically Bluetooth and potentially Wi-Fi, but, you know, mostly Bluetooth devices, you know, because we don't have, you know, a good like electrical way to just run a wire to them or from them and get out some sort of, you know, square wave that's telling us, or, you know, some output that's telling us what the time is. But I you know, the fact that you're using kind of like Adafruit parts, like, leads me to believe that, like, if this doesn't already exist, that there's going to be something that will be easy to modify too. Let me quickly go to the lab streaming layer website. And do you have a link to that page of just all interesting applications that people have submitted?
Yeah, let's see if that is right here.
Okay.
Let's see here. I don't think this is what you're talking about. Here's a. Oh, sorry. I'm just seeing there were some chats there, and I'll address those in a second. Here's a link to the first and only other contest that we've done. There are the winners and runners up of that, but I think you are looking for something else.
Yeah, but definitely check chat. I see Nivi's asked a question.
Yeah, let me here's the where is it? Yeah, I'll look for that link in a minute, but here's the link to the contest, and I think that you should be able to see the people's submissions for the first phase. Yeah, if you go to participants, maybe.
Yeah,
I don't know.
I think that's what I was looking at. Yeah.
Cool. Yeah. So somewhere on that contest, you can see all of the different submissions, and it's cool. It's really cool seeing things. A lot of people have submissions that, you know, they're like, okay, I don't know if that's quite going to work. But then a large majority have really cool ideas. Jenny, thanks for posting the contest link. See, John is asking about so oddball paradigms. I don't know if we covered that already, but I don't know. I don't remember enough about oddball paradigms to talk through that, but maybe Morgan does.
So oddball. The reason I asked is, and it's something we talked about here a little bit in general, is so auditory oddball is the classic one. But there are visual oddballs paradigms as well. But it's just you have standards and deviants of anything, any kind of sensory item, and it can be, you know, a relatively low level difference, like a tone difference, or it could be something a little bit more abstract or higher level. But like a tone difference would be the obvious one. But there's a lot of interesting neurobiology around the way that the kind of probability structure of a stimulus set is encoded or learned, and how deviations to a kind of locally learned probability structure are reacted to by, you know, brain responses. And that's like oddball paradigms have been around a long time. The neurobiology of this kind of statistical probability learning stuff, that's maybe some of that is a little bit more recent, but in any case, like it's a the auditory case is a simple paradigm that gives you a really robust EEG EEG differentiation, EEG signal with a small number of trials, and it's super easy to do. And in the as I was saying earlier on, like it has interest and potentially kind of clinical value just as an index of certain fairly low level properties of like CNS function. So it's not like niche auditory stuff per se. Like you don't have to be only interested in auditory information processing. Like people are also interested in oddball responses, just as like brain measures, basic brain indices. And I'm pretty sure that's it. I haven't looked, but I would bet my socks, and I probably have read it at some point, that there are oddball paradigms for somatosensory, and I wouldn't be surprised if they used a lot. But that's just a guess.
Yeah, no, that's really interesting. Yeah, this definitely seems like this could be a helpful a tool for that oddball paradigm, especially because you can introduce oddballs not only in intensity, and if you go buzz, 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 or you can do location, buzz, 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 and see if there's a difference in the ERP you see there, or any of the other signals you get. Yeah, so very cool.
Yeah.
Let's see, I want to answer Neil's question here. So Neil, thanks. You're saying, the future of neosensory in the next 2 to 3 years, are we going to be expanding on the current wristband for people who are deaf and hard of hearing, or working on implementing other applications other than sound transmission? So we're going in both directions. So, we care a lot about the deaf and hard of hearing communities that we've been working with, and we want to make sure that the product that is out there already is as good as it can be. And there's so many other exciting things that we can work on. So we're definitely focusing on those, and we hope to be launching a few new products that right now are still under wraps, but soon we should publicly be talking about that aim at different target populations. And then, of course, we're always waiting for folks in the community to make their own applications that they can own, but that people can buy wristbands and have whatever it is that somebody in the community figures out there. So lots of possibilities for future directions. Thanks, Neil.
Yeah, and will there be a paper on, or is there already a paper on how you're converting speech to the four sensors, to the four motors?
Yeah. I can share the preprint of that. That should come out
cool.
soon, I hope.
Yeah, that'd be really helpful for one of my use cases, which is working with aphasia patients, specifically larynx ones, right? So we have a software platform that we help train patients with TBIs, and a lot of them are aphasic, and just getting them to interpret what we're trying to get them to do is really hard. And if there's another way that we can reinforce what we're trying to do, we do some visually with the mobile app, but if there's a haptic, if there's another input, it could help reinforce it for them. So be super interested in seeing that. That'd be cool.
Cool. Yeah, I'd love to hear more about what you're working on and where that goes. Yeah. So so there's a lot of details here about some of the research we did, but under device and under algorithm, we talk a bit about some of the processing that goes into turning sound into the different vibrations. One thing that I didn't mention before that might be of interest to folks is that we do implement or we do take advantage of this somatic illusion that happens with vibration. So there's lots of different illusions that you can elicit with vibrations, and one of them is that you can create illusory points on the skin between two motors. So if I turn on this motor, I feel it at this point on my skin, this motor at that point on my skin, and if I turn them both on halfway, I feel like there's a point halfway between the two. And if I turn one on more and one on less, I feel it move towards that. Yeah. So we do describe that here. We just link out to a paper that does a great job describing it. The SDKs currently don't have that embedded in them. I want to add that. I want to add it so that you can say, vibrate location, 2/3 along the wristband, even if that's not a real motor. But right now you can easily say, okay, turn on motor 1 and motor 2 at half intensity, and you can control this illusion yourself.
That's super cool.
Yeah, that's been a lot of fun. It's really cool to, I know there are only 4 motors on this, but when I, take a slider and make the vibration crawl along my arm, it feels like it's very gradually moving. It's been fun.
Yeah. Okay. Because I didn't expect anybody to necessarily, come up with something on the spot. But I mean, I was interested to know, or see if anybody had good ideas for things to turn into, to be converted into these haptic responses. I mean, you've got the infrared example, which I linked. Your first developer conference or your first developer contest was somebody did air pollution, I think.
That's right. Yeah.
Right.
Mm-hmm.
And is that the guy that also did the iOS
package? That's right. Yeah. Mm-hmm.
Okay. Yeah.
It's on his game.
Gotcha. And yeah, I mean, well, certainly, it's hard for me to think about any of this and not be basically a psych experiment or stimulation for neuroimaging. So right. I don't know if I'm the best example or best person. Yeah, just one second.
Yeah.
These new phones have LiDAR sensors, and I haven't gotten to play around with too many of them, but I work a lot with the blind. And so we do a lot of that for, non-visual travel, a lot of haptics. And because, ears are very important for blind people to understand the world around them. So you can't be putting things in there for assisting in travel. And so, yeah, we also went the best, the around the body route. Mm-hmm. But it would be super cool to think about, hey, if you're walking in a direction in the area in front of you, what objects are coming towards you? Because I'm looking at the paper and it looks like, yeah, you're mapping out basically a one-dimensional space across the motors and sort of saying, how intuitive that might be to say, okay, this one is, on your left side, and then around here is on your right side, and then how does that go around?
Yeah.
Very exciting.
Yeah. We worked with Google Acme Labs for a little bit. They had LiDAR set up in their entire building, and so we had one of their friends of the company who was blind wear a vest, and he, different layers of the vest told him okay, he could enter into his iPad, I want to go to the room 203 or whatever, and one layer would tell him, okay, here's the navigation to get there, go down this hallway, this hallway. One would tell them, by the way, there are objects in front of you over here, because with an entire building decked out in LiDAR, you can do that. And they also had some RFIDs on all their employees, so you could know who was around you when a person was walking towards you, and maybe who it was also. So that was super fun.
Pretty wicked.
But if
you get that on the wrist, even better.
It's even better, and I'm wearables are so hard to build. There's so few, just relative to making a wristband, making a lot of smart textiles or fabric-based anything. It's so frustrating to sell. So it is it's a cool way to actually package it up. That is and the deaf use case is such a killer app. That's awesome. Yeah.
Thanks. Yeah, and you're right about those difficulties with fabric. We were excited to tackle the challenge of the vest, and we might come back to it. But yeah, it's difficult. How do you wash it? Do you unplug parts of it, or do you waterproof it? And yeah, they're away. You know, what if I want to wear my vest every day, but it gets, you know, smelling? What do you do on laundry day? Like, you wash it, you have a second pair. Can you unsnap some of the wearables and snap them onto a different shirt? So many different things like that.
You could do what everyone else does and just say you can only wash this 8 times and then it's destroyed. And it's like that is not sustainable.
Literally not
planned obsolescence. Hey, I had a
Right?
question.
No, that's the most profitable.
Is the Buzz waterproof actually? Speaking of, like, you know, use cases for it,
Yeah,
can
so
it
it's
go
water
into like wet
resistant.
worlds? Okay.
So you can't go swimming with it, but you can, you know, walk in rain with it. Yeah, we're excited to make a waterproof version so that you can go swimming, but not yet. What were you thinking? Do you have an application that you're thinking about?
Yeah. Yeah, I was thinking just like what environments I could use this device in. And I was also wondering what sensory input I can put into the device. So can I send signals via the USB-C cable or just the microphone input?
So via USB or Bluetooth. The microphone input just responds to audio in our predetermined way, and so probably what you'll want to do to control it is to either wire it up or, more realistically, connect via Bluetooth to it and use that Bluetooth connection to say, hey, turn off your algorithm where you're listening to audio and start listening to me, and I'll turn on the motors.
Okay, yeah, because I was thinking a cheap way to hack the timing problem, if like you don't want to rely on Bluetooth, is like have a central source emit a noise, and that gets recorded and marked as like a vibration, and that way you can clock it to your EEG receiving device. Back in the day, we used to hack a emotive where like we'd sacrifice one electrode and put it on the corner of a screen for SSVP. Just because the jitter in time for these devices is hard to sync with like a host receiving device.
Yeah.
But
that makes sense.
But yeah, it's a really cool device. Would you be willing to give a discount to Neurotech X members? Question mark.
I would if I was in control of that, I would send you all one for free. Let me ask.
No. I mean, we gotta support the people, right? That make such awesome things. Like, wearables are not easy to make. It takes time, money, and a lot of engineering, and, you know, plastics, and outsourcing to foreign countries, I'm sure, and importing back from foreign countries, I'm sure. And it's always been a hassle, I hear. I've never built the device myself, but yeah, I don't think it's easy.
Yeah,
it's definitely not something you can do just because you want to. It definitely does. I mean, you could, but it takes a lot of resources to get it to the point where it's you know, very robust. So yeah, I know we ran a discount for anybody signing up for the contest. So we can see if that's still running or not, and either you could, you know, take advantage of that discount and sign up for the contest, or not sign up for the contest and get the wristband anyway if you buy it.
Yeah, I mean, so if I signed up for the contest today and got a discount, when would a device like arrive at my house? Imagine I live in like California. Like, what's the turnaround time? Yeah.
I think we ship in 2 days.
Oh wow.
Shipping.
Okay, cool. So it's not like 3 guys in a garage, or is it? Like, you guys have like
there's 20 of us.
We'll solder it up for you.
We are on Amazon. We've got a whole inventory system going. We're doing it for real.
Oh my god, I can buy this on Amazon. Holy cow. Oh, so you guys have a real... Wow.
Well, that's great to hear. That's good to hear.
I just checked out the pricing, and everything else, like working like targeted at people with different needs, is like thousands of dollars, and you guys are like such a good price relative to like so many other assistive technologies.
Thanks.
I mean,
thank you. Yeah, we want to get it lower, of course, but
yeah, but like for initial there, it's not like $15,000. So I'm like, yeah.
You're making me feel guilty for asking for a
discount.
I'm like, oh yeah, I see it's $400, but can I pay like $350? You know,
like a month's rent in Arizona. You guys can all feel jealous.
Yeah.
Oh no, that's right. If you're in California,
laterally, have you worked with them have you worked with them bilaterally and seeing like what you can do with that? I mean, it seems like a very interesting possibility, right? Now you're working cross space, and I don't know.
Yeah, a little bit. Yeah. Yeah, one of the times I've been hooked up to two of them for the longest amount of time was when we were doing a lot of VR research stuff. And then you could have, cool inputs on both of your hands and you're interacting with things in VR. But yeah, we've talked a little bit about, and Jenny, by the way, let me say, first of all, thanks Jenny for posting all of these comments. Jenny is a community member who was in the first of our contests and since has jumped on board with us and helps manage the developer community. So if you go on Slack and we don't answer anything, she will definitely make sure. So thanks, Jenny, for carrying things along there.
Hi, sorry, I can't do one. I've got small humans, but just hello, everyone. It's so nice to hear all the excitement around Buzz. It's awesome.
Yeah.
So, I have another use case that I was thinking about we have a couple patients that we work with that have hemi neglect from their injuries. And like one of the common use cases, this sounds ridiculous, but it's true. They'll like literally, well, they're not restaurants now because COVID, but they'll literally walk to the bathroom and turn around and come back and have no concept of where they were. Right. So we worked on things like putting tiles together and like having like essentially like a tracking system essentially built into their phone, but it's a pain for them to like look at anyway, but I think this could somewhat be interesting, like a warmer, colder sort of thing, like and sort of like have the sensors firing in different ways that like, and they could wear it in their injured side potentially, because that's the side that they'll have the problems with managing with, and potentially like a way that we can like kind of guide them essentially in the right concept and the direction.
Yeah.
I mean, I know this is not nearly as interesting as the MEGs and stuff like that, but it's these are sort of use cases that I deal with more commonly. I want to integrate more EE2 work into the stuff we do, but right now it's just sort of like getting over the hump of like getting them to get on with things, but we do want to filter some of that stuff back. But I do have some really interesting use cases. I think some interesting use cases. So.
Yeah, I find that super interesting. And honestly, I mean, you kind of hit on a good point there where you said, they could look at a phone, but that's distracting. And I think a lot of the best cases here are cases where, I can give you this information visually. It's high dimensional. It's not just a buzz and alert, but I don't want you to look at your phone the whole time. Like, a lot of Muse's stuff is really cool. Some of it's audio, but like, I could look at all of my different waves while I meditate or something, but then in my meditate, I'm staring at the screen, but you could feel it. So yeah, I think that's a good intuition to see if you could hook this up for them.
A lot of patients don't want to have the concept of, feeling like they are being seen as, like I'm staring at my phone the whole time. It becomes like their own kind of internal stigmata in some senses, so it's, if we could find a way to kind of like remove some of that could be really, really, really fascinating, I think.
Yeah.
Really cool. I mean, you and I were talking about this the other week, and I'm fascinated with trying to figure out a way to kind of like integrate it into the stuff we're trying to do. It's really interesting patient. And the thing is, our patient populations are so diverse. There's so many different challenges that we incur, but I think there's a lot of different things that with like just reading some of this paper, I mean, could be just fascinating. Like we distill stuff for aphasia patients, we distill stuff and just give them the most relevant stuff as pictures on the screen. But if we could figure out a way to like transcribe that into the device, that could just be fascinating. I think it could be really interesting.
Yeah.
So, but
cool.
Thank you for coming. I really appreciate you coming in and talking to us. It's really cool.
Yeah, absolutely. I've been meaning to come to Hack Nights just for myself for a long time, so I'm happy when Morgan asked.
Cool.
Morgan,
so someone mentioned this idea of like long recordings. As in like it's meditation. You're talking about meditation, right? And you're saying it's a bit of an ass to be checking your phone all the time and you're kind of coupled to your screen and stuff. But so it reminded me of this other kind of project. At least it's a project idea at this point, but I have like some of the machinery in place to do it. Is like auditory ERPs with EEG in a kind of naturalistic context, as in not just sat in front of a screen, but kind of going about your a few reasons for wanting to do that. One is to because it's interesting because it's naturalistic. Another, or at least sitting in front of a screen is not something that's a normal thing to do. Okay, that's not exactly true, is it? But the way that we do it in cognitive neuroscience experiments isn't necessarily that normal. But also, you could get a lot more data if you could have some kind of like passive stimulus delivery that's being done at multiple kind of points throughout a day at kind of scheduled intervals. And then you treat that little window of 10 minutes or however long as your your experiment recording. And then if you can do that kind of for long periods and maybe multiple days and weeks and whatever, then that's a way of getting like a hell of a lot of ERP data that whereas normally people will like come in, even if they don't come into the lab, they're still like going to sit down in front of a screen and do stuff, and it's just not plausible to get people to do that at an extensive amount of number of hours, right? So one of the things I had in mind was, okay, well, I just want to like play sounds in people's ears, get them to wear headphones, but play some sounds every now and then, and just catch some ERPs for a kind of 10-minute little period, like several times a day, let's say, and maybe ask them to stay still while that's going on. But maybe we just deal with the noise. Anyway, it's easy to think of a summative sensory version of this, and it would even be better because you'd have the wrist on and the wristband on, and you wouldn't have the so maybe there would be noise or distractions around, like depending if you're doing something else with your wrist or whatever, right? So you want to kind of keep that relatively, but it's not like there's going to be ambient room noise or conversations or all kinds of things that would get in the way of the auditory version of the experiment that I was talking about just now. And you'd have to have headphones in all the time. I think about it. I think, well, the thing that I was interested in with the idea of this experiment, it actually makes more sense to do it as a summative sensory experiment than it does to do it as an auditory experiment. And the reason I came out for doing it in an auditory experiment is because I thought it'd be really easy to do. So that's interesting.
Can you? Does the wristband have an accelerometer itself?
No.
No.
Unfortunately, it almost made it on.
Gotcha. Yeah. I mean, these days, like, it's getting to the point where you can kind of put everything on.
Yeah.
Almost. Yeah. I mean, it's a thought, right, John? I mean, the reason that I kind of liked the auditory was something like the C-grid, where you can have the electrodes, kind of like taped behind the ear. You would want something like Neurosity, like up above.
Yeah, but Muse would be good for that. Muse would be right for the EEG. Yeah.
And
C-grid's probably better. So
I mean, you could certainly have it such that like the EEG could tell you when the person's moving about or not, and basically like have still be intermittent, but like decide on when to do that when the person's got some downtime. I think somebody or Google Scholar sent me something that was citing Kyle Matheson detecting like standing versus walking from the EEG. And I can't link all of these, but like several people have submitted EEG proposals for the contest.
Yeah.
I mean, like one's obviously got an emotive SDK, and or has read their docs. So somebody's suggesting electrical impedance tomography, which like that's like I like it hardcore. I'm Still not quite sure why, but I don't know if everybody's seen these. I can't link to the. I can just link to this page.
If you click on it, it doesn't.
Yeah, I can click on it, and then I get a. It's oh no, you're right. You're right. Okay.
Yeah.
It didn't look like a.
Yeah, it's just a modal, but I think you can link to it.
Sure. You're absolutely right. So here's somebody who knows that they need to pay for the Python SDK separately for the emotive.
Yep.
Yeah. I mean some I mean I don't have the kind of like the same kind of use cases in terms of like clinical populations or people with potentially with differences in sensory inputs, but yeah, trying to think along John's lines of like things that make just as much sense or even more to do. So I mean, I checked into the lab streaming layer, and like it's interesting because I was expecting to see a whole bunch of people doing things with either feathers or other devices, and like off of Adafruit and or microcontroller as keywords in lab streaming layer Slack. I find only one discussion, but it's the contract group that OpenBCI works with in New York.
Wait, Push the World?
It's not Push the World. Connected to the Future.
What are those?
I feel like I'm coming up with marketing slogans. Give me 1 second, and so I'm on way too many Slacks.
You're slacking, bro.
Connected Future Labs. Here, I'll paste. And TS Tenor, who did who I want to talk to about built wheels for lab streaming layer, especially with ARM. So I was just talking about somebody. Did you see this, John? I found a really nice blog post explaining how to get Muse LSL running on Raspberry Pi, down to like how to get the CMake working, get the CMake project working.
Yeah, I think I tried that. I think I came across that, and I don't think I got it working, but
no,
that isn't necessarily it was wrong. I think I might have had the wrong Pi version, which might have been the reason for it.
You mean you weren't using a 4?
Not run out of time during the weekend or something. I don't recall off the top of my head, but I remember like seeing that, thinking that would be interesting, trying it, and then not getting to the end. But there are various reasons for why that could have been the case. Okay, but you needed to do all there's loads of stuff you need to do custom with the.
Well, so
Pi. It's like
the reason. Well, I mean, yeah.
I was a bit distraught by the kind of custom, compiling of various libraries had to be done. I guess I shouldn't be too surprised.
Yeah, or certainly this is some old stuff. So I've actually John, I've been working with a student at UC Davis who we got further, but it's really just getting TS Tenor, or TS Tenor seems to be the guy that does all their PyPy packages, and this is relevant because what he's saying about getting timing information from the Arduino microcontroller family. He's like, at this moment, LSL uses Boost for the networking part, so it's not directly possible to stream from the microcontroller. Stream timestamps from the microcontroller is but anyway, I'm gonna follow up with TS Tenor and see what we can do with that. That's also super relevant because these are the free EG32 board is using STM STM32s, which is a related microcontroller. So anyway, we this is about getting experiments, being able to use these for experiments, Mike. But
right.
I mean, honestly, you don't need it. Or the way Dave McGonigal would use, like vibrating stimulators, like potentially he would just like rub your foot while you're in the scanner and just do a block design where he's just like, I'm gonna rub your foot for 20 seconds, and do like on off.
Right.
Which,
yeah.
Which for fMRI could work, but I mean again, like what's just awesome about it is that you've got it so nicely packaged that if we can get the SDK working with the timing information, we can do a lot more subtle kind of paradigms.
Yeah. Let's see. I was going to ask if you can do the trick. I think John was talking about it, or sorry, I forget who was talking about it, about stealing an electrode. But I guess you're talking about consumer devices where you can't take an electrode and rest it next to the wristband to use that.
Yeah. I mean, so yeah, I forgot what did you say the limitation was while we're connected with USB?
It's on the bottom of the wristband, so you can't really easily wear it. That's where the port is. So
I see. Yeah.
You kind of wear it if it's sticking out.
You could have it lying. Well, yeah, I see. Well,
yeah, and now I'm not gonna. This is not endorsed by Neosensory, but there's no reason you can't take it apart and get that USB port stick out the other side.
We can have the watch have the wristband open and then like duct tape it to your wrist.
Yeah.
And leave the USB.
There's also USB 90 degree like angled connectors, which you might be able to just like use that and have a cord at 90 degrees going in. Like,
oh, I like this. I like this.
Yeah, I think that's great.
Something I'll paste it, but just think about something like that ugly Amazon link. God, Amazon, you're so ugly with your links. But anyways, yeah, something like that might work. We're hackers, or we can take it apart. If we take it apart, are you like Apple and will sue us and hunt us down?
Is it really USB-C?
It is USB-C.
Oh, okay.
They're next generation, yo. They're thinking ahead. I mean, it's awesome.
That is. I mean, I gotta say, or like I don't know if Ryan's still on, but don't get him started about micro USB.
Would he be happy or mad that we have USB-C?
It's apparently a trigger.
That's so funny. We had a long conversation, I remember, about which way to go. Are we going to be too early, especially with the. If we have an elderly population, no one's going to have USB-C, but I'm glad we went this way.
So is that's how you charge?
Yeah.
Yeah, gotcha.
What's the battery life, essentially? I mean,
Easily 24 hours. If it's like vibrating most of the time, and it charges in 20 minutes, sometimes it lasts, several days.
gotcha. Okay, cool.
Okay, so I mean, you've got an incredibly, like Abik said, like incredibly well priced, wearable device that like solves, all sorts of problems, and potentially adds value to the scientific enterprise. But the really important question is, what do you want to do with your muses?
Right. Yeah.
And can we help?
Yeah, I'm definitely interested in hearing more about the EEG notebooks too, and seeing if I can become a user. But I'm also, let's see, probably gonna have to jump in not too long.
Sure. Anytime you need to. Yeah. I did want to, try and get you using our notebooks. Since now you have 3 headsets.
I know. Well, and so let me. Yeah, one of the things. So a lot of the things that I want to do, not all of them, but a lot of them have to do with wearing the wristband. Or I have a vest prototype here, and so I can hook it up to a whole bunch of motors.
Yeah.
So I'm very interested to see what I can do with that. I wanted to try to like piggyback on EEG 101 apps like framework, but I wasn't able to quite get that, even though it's open source. I wasn't smart enough to.
If you're talking about the EEG 101 that we've got listed, yeah, like that's on my list to bring up and say, like, why are we still listing this if people can't build this project and it's not available in the Play Store,
Right.
And it's interesting, or like I think I've got a collection of like 3 or 4 apps that I think are super interesting to research people. They're not EEG apps necessarily, or biosignal apps, but it made me want to come back to, like, we should have a good example for for frameworks, for mobile frameworks. And I mean, it somewhat came up, John. Run it, I think, joined from. He joined the Code Sprint and was like interested in mobile stimulation, and he was pushing that Mind app, or Mind framework, but spelt with a Y. Super Silicon Valley, even though it's German. But I just think of that Brooklyn Nine-Nine where it's like, I forget, it's like Toddler. Yeah, her app was named Toddler, and he's like, how many D's? Or like, she's like 4. So like I don't think anybody's been able to get EEG 101 to build. I mean, even I don't know if you had checked out the project, or
no, I checked out the project, and I was actually able to build it.
Did you?
A couple of years ago.
Oh, okay. Yeah. No. You got me all excited.
I know. I'm sorry.
No, it is not aged well. Or and we had I don't know if anybody remembers this from the beginning of the year, but there was this art student that joined from Montreal. Anyway, he was also trying to build it and had given up. It was getting into kind of like Node React library issues that I couldn't disentangle. I mean, I've still got I've kept an Android phone around specifically to see if I could get something running, but yeah.
Well, I could take a look, maybe that starts to sound like up my alley.
Okay,
you can take a stab at it. Yeah, fair enough.
Oh, awesome.
I haven't gotten that for you, so I can give it a whirl.
Yeah.
Well, So any last questions for Mike? Anybody? Really appreciate you coming. And
yeah, and I want to, I definitely, I'm super happy to have gotten a chance to talk about NeoSensory, and I want to see about a discount code because I'm all about that.
Okay. I will follow up. I will follow up on that too.
Do.
And if any of your participants, I mean, I'm already on your Slack, and I'll do an intro or something. But and basically just say, like, if somebody's trying to get EEG running with the Buzz device, like we would be really happy to help, and it seems like several people have already suggested it.
Yep. Yeah, I think people would super appreciate that. And I think I'll jump on next week to also take you all up on that, just for my own personal gain, because I want to hear more about EEG Notebook, and I think it could be could help me, unblock this project that I've been trying to work on since even before NeoSensory. I was trying to hook up vibrating motors and EEG, and so
haven't
done it yet.
So and it might not be the perfect framework for you, depending on what you're trying to do. Because if you want to try and do real time stuff in a loop with the device, then you might want something like the time flux mind effect that we're going to talk about as well.
Okay.
And but you'll come back and tell us more about what you're trying to do.
Yes, perfect. Let's do that. Yeah. Perfect.
Okay.
Thanks, John, for the overview talk. All right, I'll look at that, and then next week or when I come back, we'll talk about if that's the right tool or if there's another tool out there. But yeah, thanks for letting me talk to you all about NeoSensory, and I'm looking forward to getting y'all's help on some EEG stuff.
Great. And thanks, Danny.
Mike.
Yeah, thanks, Danny. Yeah, thanks, y'all. And don't hesitate to reach out with any other questions that come up.
Cool.
Take care.
All right. See y'all another week. Bye.
All right. I mean, super, like, it looks well made, like an actual consumer device. Yeah.
Pretty
and
cheap.
It lasts more than 2 hours. And it lasts more than 2 hours.
Right.
So
right.
This is great. Oh, that was cool. And we're done. I think we could plug it in from the floor.
Wasn't entirely clear. So can you write some Python code that tells it to, go boom, and some that goes right? Like, does their API allow you to do that and then remotely program in controls?
Yeah. The API seems pretty rigorous. I mean, it's great. Well, it's granular enough that you can do a lot with it. It seems like anyway. So.
Yeah, that would be just a really, really cool set of experiments to do, right? Just write out some interesting little things and then measure some EEG responses and see what you get.
Interesting.
I mean, the main, one of the things that's held back previous kind of, these kind of somatosensory stimulation paradigms is really the complexity of the device you need to do the, to have that kind of, high dimensionality, if you will, or, So again, I just remember Dave, some of the setups that Dave would do just because building his own haptic device, and getting, more than one frequency was already a big deal for him. and they've obviously done a lot of work on this, and I think it came from building a vest, crazy 400 sensor vest or 400. Yeah. I don't know if this right angle USB-C would be enough to.
I think you'd probably just tear it apart and basically just take the ribbon out and just run it along.
There's got to be a more a lower profile one of that, right? No.
More. I have to show you guys something. This this is like the watch that came out of the Chaos Communication Camp as like their badge, and it's called the Cardio Watch, and the USB-C is in the right position. And I couldn't mention it, like I didn't want to mention it because I'm like, oh man, like, you know, like no accelerometer and shit, but
No,
this watch is crazy. I and the craziest part is like, I mean, the buzz thing is cool, but it's like I think it's not as cool as the cardio badge. And the cardio badge is open source. Like we could literally have Neurotech X build 1,000 of these devices, and I think I don't know. I hate to.
Chaos makes great stuff.
Yeah, but they only make it once for like the people who attend camp, and camp is every 4 years. So like, I mean, here, can I share the screen and show you guys a demo of the hardware on this watch?
Sure.
I have this watch in storage, but it's just let's see. Neurotech X Cardio. Okay. So this watch looks much prettier normally, but this hardware page has like the nitty gritty details. It's an elastic band, like very easy to fit. Has like a very beautiful OLED display. Dual core ARM processor, so you can build it in C or in Rust or MicroPython. It has Bluetooth. You get like 1 mega flash, so the like primary initial boot is going to be 1 meg, which is pretty big, and 8 megs of storage for data, which is okay if you're not going to store too much and just send it to something else. And there's a lot of sensors that you can, start collecting data from. Accelerometer, you get the gyroscope, there's a magnetometer, you get the temperature, humidity, all these other things, ECG, and the pulse sensor is like an infrared. Oh no, it's not an infrared light. There is an infrared light though, and a sensor for it. But the ECG is like your regular like not EEG quality analog to digital converter, I guess, but like good enough for heart rate and EMG kind of activities. And it has a vibrator motor on it, and so it's like just this amazing device. You can build it yourself if you have like it's open hardware, so we could like all pitch in and have a load for us made, if we wanted to,
but
and play with it.
Yeah, no. I mean, it looks cool. I would, yeah. It's important to remember that it's a different vibrator.
Like, yeah. Okay. I am not saying it's the same type of watch. I'm not saying it's like the same type of product at all. I was just like, if nobody here knows about cardio, they should. Because like it's a watch that is it's a real watch, and it kind of does things that you might want when you're looking at like these types of devices. And if you don't need the quality of input for the haptic feedback, like if you're just notifying if the doorbell rings or something, you just need a vibrator, right? You don't need an array of them. So
like the example I was saying as well, I mean, same applies. Like in the first instance, you'd be like, well, slow vibration versus fast vibration, or even just response to a vibration full stop, or some kind of quick poke. And the dimensionality of their device is very interesting. I think it's more interesting when you're talking about kind of representational spaces of encoded information rather than low level physiological responses to perturbations.
Yeah, I mean that was key. I posted this like super early on, but Scott did this. Scott Novich did this thing. What was it called? It was. Oh yeah, sensory hacking 101, and it's up at before or just a little bit after 7, but it's like if an Apple Watch does like if you all you need is an Apple Watch, like the Buzz is not for you.
Yeah,
Right.
that's true.
And again, like that's what be really interesting about their speech paper, or like how they're converting the speech into those into the vibrations, because I'm sure you could do that in a couple of different ways and achieve somewhat similar performance, but I'm not 100% sure, but
Well, you have to transpose sound or words into like 8 bits of input. I mean, that was my understanding of the problem. It's like you have sound waves, and then you have to transfer it into a signal that you have like 4 outputs.
Yeah,
and,
well,
and
yeah,
each
4
output can be
8-bit
on or
outputs.
off. Yeah.
Yeah, exactly.
But yeah, I couldn't think of any interesting experiments where I need like that high resolution for anything. Like I was like, oh yeah, I can get like a bunch of rowers on a crew team to use like this device to like synchronize, But what I'm really thinking is for Chaos Communication Congress, it happens in between Christmas and New Year's. It's coming up. It's fully remote. I would love to. They do like all kinds of cool stuff, not just security talks, but like mind body stuff too. And it'd be cool to have like synchronous yoga, and the leader like signals the change in movement by like the vibration, or just like I don't know. There's like something nice about having a haptic feedback in a group of people. Like there's some idea to explore there with this kind of device. I don't know though for a high resolution like Buzz. I wish I could think of a cool experiment.
It's not this year, is it?
Yeah, it's remote. It's remote.
It's coming up.
Yeah, so sign up is the 12th. The last sign up, if you don't have a ticket already, and you need a ticket to participate in like more of the group activities and to host workshops and stuff. Otherwise, the live streams are free and streamed live. But
it's also on the radio.
Yeah, it's on the the media.ccc.de.
It's on the radio.
They're still physical.
Yeah, Noise Bridge every year streams the radio and the video conferences. And yeah, they have a really good live streaming and like event setup. So I'm not worried that it will be all that like convoluted this year. But they do, I hope, have more neurotech talks in the next couple of years, because I know sometimes they are very lacking, and especially because of biosecurity and all of that now being something everyone in the world has to deal with. I hope people participate in those talks and events.
I mean, this is the first place that I saw Jean Rintoul present her Spectra.
I met her there. I attended that talk live and talked to her, and I was like, "Holy cow, this is amazing!" Like, I was like there. It was that was a cool device, and it was like,
yeah. So
there aren't many presentations in this space at CCC, and so there should be more. It's a true fact.
Totally. So let's I mean, thank you for bringing this up, because I definitely want to try and see what's going on, see if there's anything to sign up for. At this point, it's probably not. Next week, Andreas Forslund is coming from Cognition, and is going to talk about the recently released Cognition 1 that we looked at last week, and was, kind of like the keynote big release associated with Neurotech 2020. So this is like a AR BCI, it's AR EEG. What else? Like speech response. Like it's got
Swiss Army.
Yeah, like anything, any assistive technology and or biosignal approach plus AR is all connected. And I got to catch the talk that Cognition did today with the CEO of NeuroVR. I think is or is it NeuroFit VR? Anyway, there's like a VR VR company, I think, focused on like pain management things like that. But it's definitely going to be a bit of a problem because they still haven't released. So like they're at the point of like, I think, deciding which research labs are going to get devices first. So yeah. Anyway, I hope we'll be able to get enough answers so that we're not waiting for another 6 months to see. But still super cool that Andreas is going to join us. And anyway, that'll be next week. I wanted to put it to people whether we're going to meet Christmas Eve and New Year's Eve, because the Hack Night falls on exactly those days. And for say John on the East Coast, it would be literally up to New Year's.
Me too.
Yeah. You guys are great. Maybe one day there'll be a Hack Night Christmas, but not this year. Hack Night New Year.
So if you don't mind me wrapping presents and
Right. Understood. Yeah, I know Neurotech X Paris is going to be away. Well, I think they're going to be away because he's not sure if you go on lockdown again, but
but opening back up for Christmas, Francis.
Somebody's game. Oh, okay. Ori, did you have a question?
I did a while back, but I feel like the conversation has kind of gone way over the question.
Well,
but
questions are always good.
All right. So I think my question was more around like when everyone was talking about like EEG experiments. I was just kind of curious about what goes into making up these experiments in terms of, I know they're the SSVP ones and the ERP ones, but more in terms of, okay, you want to, a proper scenario is like people with like ADHD, for example, and you probably want to record over a long while. So let's assume you're recording over a short time. How do you essentially generate experiments that are able to detect, or I don't know if that even exists, peaks for distractions when they're doing stuff? And is there something that happens with some sort of pattern or something like that? I was wondering if anyone had any experience with that.
Yeah, definitely. So here's I forget. I think Ryan's watching the current game developers conference, and but he mentioned NeuroRacer, and certainly NeuroRacer, when Omar joined us, he was talking about his work in Ghazali Lab working on this project that kind of became the scientific studies and the basis of Achille Interactive's most recent like FDA approval for an ADHD digital intervention. And I forget the name of Achilles' product, but this is NeuroRacer's, and plus there's a bunch of YouTube videos showing NeuroRacer. So this is from Joaquin, who's one of the professors at Neuroscape now, and actually also, or at least did until recently, Joaquin also ran the psychiatry department's digital health grant program. Again, I can find links if people are interested. But this example is, so the driving gives you this kind of like continuous performance task, and you can digitally control how difficult it is to stay on the roads, kind of thing. But at the same time, as you see when you check out some of these videos, they're also asking people to do kind of like a delayed match to sample kind of thing, or a object or identification, and press a button if you see this. Don't press a button if you see something, a different class. And so streets are like kind of signs that go past on the roads are coming up, and you're supposed to do stuff for a certain class of signs, if you see what I mean.
Oh, okay. And so in doing that, then you kind of record the EEG at the same time, I guess?
Yeah. So this is actually either with EEG or in a scanner, in an MRI scanner. So Omar, who joined us like a couple weeks back, did a lot of fMRI studies with this task.
Oh,
but they've done EEG as well.
Oh,
and I mean that's just one where it's like, because like Omar said, like GazLab is focused on healthy aging, and so what you see if you like look at people across decades is in these multitasking scenarios, basically divergence of performance and the effect of the distractor task, and kind of like, yeah,
sounds good. I'll definitely go watch the video you shared.
There's certainly other, this is just one that I happen to be familiar with, but like, it's not like the only kind of distractor you could use, but I do kind of like this one, and in that, like I think if we are like, it would be easy to take driving games, and I'm thinking about, we've talked before with again, like Omar and I have talked before about taking like open source driving games that you can find on Linux, and you can because this is really bare bones when you see this, right? And you could with a lot more realistic kind of passing natural scenes, you could have make finding say animals in the tree line or something like that, and you could make those tasks much harder, be a kind of like signal detection task as opposed to the psych task.
Nice. Sounds good. Thanks.
Or, by the way, on this question, like I don't know an awful lot about this topic per se, but I believe Eric is also working on this for his masters. I don't know if you kind of ran into Eric, but he's he was with us a few times in the GatherTown last week, and he's contributing a lot to the project at the moment. So and he's on the NeurotechX Slack, and I would suggest like just ping him and say, hey, like, what are you up to here? And if this is something that you're interested in, getting into or learning more about, then just take it from there.
He had some similarly great contributions to Moab.
Oh, really? Oh, I didn't know that.
Yeah,
he's a beast. Like, he
dropped in. He said he did his usual thing where he like submitted some cool stuff, and then he also said like, it seems to me like this project should be like Pyremon should be moved and kind of like subsumed into NTX because it doesn't seem like like there's a whole bunch of PRs and nobody's responded to them. And it's funny because Alex Cramfo comes in and responds. It's just like, yeah, I totally agree.
So on the point of like PRs and all of that, same for like, I guess EEG notebooks is there some sort of like a roadmap of stuff? I saw like the Mohab stuff had, I saw you shared like a roadmap type of thing.
Yeah.
I don't know if there's one for the EEG notebooks, but I'm just wondering like, what's the direction that I know there's a cleanup first and then, but like, what's the real like end game or direction that you're trying to take things?
Yeah, I mean that's a really good question, and we have like we've had lots of discussions around this. So there's a roadmap in kind of a collective consciousness, but there isn't something that's as crystallized as it should be, and that's something we should aim to get down. But the answer to the question is we want to expand the experiment repertoire, and we want to expand the database, so that we have essentially like a large normative data set of a large number of experiments that are doing a variety of things. And that's really the primary kind of direction at the moment. And then beyond that, it's really kind of like uptake and trying to make it useful to people who want to do these kind of things in practice, which is definitely going to be a big part of our jobs over the next probably few years. So kind of supporting the community and building the community around that. I don't know if that's so does Moab have like a very developed roadmap?
No, it has a README, but I noticed like I think like a README is enough because anybody can see a README or can see something, as opposed to having to be in a conversation with you or anybody and asking questions about. So it's easier for me to kind of be like, oh, I have like 30 minutes. Maybe I want to do some little thing here that contributes to that because I see that there is stuff already, kind of stuff.
Yeah. That's good that you point that out. Yeah, we should aim to have that down. That shouldn't be too hard to put together. I'll check out what Moab's got.
So I'll post the HackMD link in the Gitter or Slack, so you can see it. But it's in the chat window at some point.
What channel do you guys talk on? Is it Slack? I heard someone say Mattermost or Matterhorn.
Well, so Mattermost is BrainHack uses Mattermost, right? And like to some degree, I would have said like instead of Discord, like use Mattermost just because a lot of like those
it makes sense for us to be on there because the entire neuroimaging community is on there.
Yeah.
And
it's on Mattermost.
Yeah, I mean insofar as like a lot of the neuroimaging community is involved in brain hacks now these days. It's not the entire neuroimaging community, but it's a lot. Then that's like the single platform apart from old like list serves, etc., where there's lots of people there. And they decided to go there because Slack was, charging them and they couldn't keep message history and so on. So it makes sense for us for this project because then we can kind of cross-link to this community that we want to kind of tap and to some extent we want to kind of bring in. But the downside to that is it's not the Neurotech X Slack, right? So we need to decide exactly what our objective is in terms of like linking across from the Neurotech X Slack to the Mattermost channel. Yeah. But I think the Mattermost channel is still the right place to have general discussions.
Well, so I mean,
yeah.
Gitter is the way we're trying to put our Moab conversation in. And it's very good conversation to have about it. I'm happy to be talked out of it, or like part of it was that we're really triaging a lot of the issues and things that are already on GitHub, or at least like that's the only real like benefit of Gitter is that like you get direct linking to your. I mean, you could do the same thing with URLs, but yeah.
So Gitter gives you some nice like GitHub issue referencing and stuff.
It's like issue referencing, and it's like it's more than the URL because it's seeing through and passing some of that information, but I also found like some things didn't work.
So Ori's just posted GitHub discussions, and I saw this come up because GitHub is asking me if I wanted to enable it for EG notebooks, which I did, but there's just like the default message at the top and nothing else there yet. But Ori, like, do you know much about this yet?
I mean, I know there was a preview about it yesterday or a couple days ago, and I can definitely like take a deeper look. But the general idea just kind of addresses this instance of, you have a lot of issues, and then you have conversations that go on around these issues, but not necessarily like, pull requests or whatever. And that's what like the discussions does for you. But it's still in beta right now, but I don't think setting it up should be cumbersome in terms of, trying to use that out. So
I would absolutely prefer to do that, as if this works in the way that you kind of expect it would do. I really hate this like multi-platform thing. And every time someone says, "Oh, we're on Discord for this, and we're on Jitter for this, and we're on Slack for this, and this Slack for this, and we're etc." Just, but there's a XKCD comic for this, right?
Yeah. There are
sounds right.
Standards. They all suck. So I'm going to create a new standard that fixes all the problems.
Yeah.
Now there are 17 standards. I have to print it out somewhere.
Yeah. But yeah, it's such a good just summary of it that because it's both like an annoyingly silly, fact of reality that you have this, this bloat of things like standards and platforms, but at the same time, it's because there's always some like, kernel of truth in the honest, new idea that they're having. They're like, actually, there's something here that we're going to do that other people aren't doing. That in the end, is it enough to make most people not just roll their eyes?
Yeah. We enabled the wiki.
and that's the place to go, right?
What's the point of GitHub wikis? Tell me why you would ever use a GitHub wiki. It's not in the source code unless you ask for it explicitly. Why bother?
So people don't have to leave GitHub.
Well, yeah.
Yeah, I think from the discussion side, it's just more like, I guess, curating it because people are going to stumble on the GitHub anyways. And it's from the GitHub, they go, oh, okay, well, the general questions that aren't like issues around software, kind of Q&A, roadmap ideas that just kind of go around there, where in reality, telling someone to open an issue becomes kind of, I mean, you could look at even the sprint that we did during the NeurotechX stuff. It's like, oh, I created a new issue for the little change there, only to realize later on that, oh, there was actually a previous issue around, running a new experiment and stuff like that, right? And so I have some considerable experience like writing code and using these tools and platforms, but the barrier of entry for somebody else who is just kind of looking around and figuring out what's going on, maybe a lot higher. Even telling them, oh, go on board to some other platform and then link it back here. And then this person has a different username there and then all of that. But what is worth looking at, but it may not necessarily be the best case, but it's just something out there.
Right, no, let's do it. Like I'm 100% on board with giving the discussions feature a spin and seeing if it works for us. And I would even say like I would dump Mattermost for that, or at least take the emphasis off the Mattermost. I mean, it was kind of an exploratory thing anyway, but because single platform actually really is a good sell.
I that there was a way to self-host something like Discord, because like the really nice thing about Discord is its calling feature. Like it has the lowest latency call features of any communication platform, the best video sharing, screen sharing, but it's not, and it has pretty good moderation tools. But picture if you could shove all of that in a wiki or something, because that it's like really nice communicating on Discord, because there are a lot of projects that are moving to it from Slack, especially now that they got bought out by
Salesforce. You thought it was bad before.
Yeah.
I mean, the only competitor I know to Discord right now that is self-hosted and like from a private communication perspective, like very nice as well as open source is Element, which is built on top of the Matrix protocol.
Oh,
and
yeah.
that just it's a regular chat interface like Slack or Discord, and the video call is done using like a built-in plugin with Jitsi. So it's the interface you're all kind of familiar with here. And I think the call feature is also using Jitsi as the backend. But yeah, it used to be called Riot. Now it's called Element.io. And it's what I used to use at work. At one of the companies I used to work at. And I use it now privately full-time. I actually tried it to convert people over just because I think we should start hosting our own data and our own services. I actually think the same for NeurotechX. I think like the more services we can provide for the community, EEG Notebooks is a great service. But imagine if like someone could just go to, notebooks.neurotechx.com and boom, all the stuff is just installed like before your eyes, like magic, and all you have to do is just plug in your little headset and there you go. And if you're a student or something, the compute is kind of discounted because it does cost money to run the compute. That's the only problem with that, is like running those kinds of services costs money as opposed to just like booting it up yourself. But if you're processing a lot of data in a lot of data sets like EEG Notebooks is starting to do and Moab is doing, it becomes really hard to process that data on like a MacBook or a laptop that's like a PC or Linux or Windows PC. So I don't know. I think the future is going there. I think we have to find a model that like lets us do that, because it will let the layperson or like the undergrad neuroscience person who's not quite on the tech side do the science side without having to worry about like, oh, do I need to install Make? What's
Yeah.
Sphinx? You know, I'm not an Egyptian, and all that stuff. You know, and so like, I don't know. I think. We have to kind of think how we want to direct that. I think EEG notebooks is great for that because it's a great starting point for that. And we have to make sure it doesn't die like other projects we've had in Neurotech X. Like you know, Cloudbrain was one project. The Android app is another project. You know, maintaining these projects is hard, and I think that's one point like Ori is bringing up is like organizing these projects and giving a roadmap for other people to like if they have time, whether it's 30 minutes or 3 days, you know, like they can make a contribution that can push the project forward. And that's like a mapping that, you know, I don't know, maybe it's very easy, but it's I don't think that's easy to map out.
So like that's something that we we have we're trying to think about the right components of doing that well. And Hubert like has facilitated this discussion with Alexandre Gramfort and Dennis Engerman, who are the M&E developers, about how to build an open source project, and they do it really well. As in, M&E is like it's got a very big community, but they kind of clearly facilitate people coming in and joining in and making contributions, and it kind of really thrives on the dozens of contributors who are making things happen. So we're going to talk to them and just get their kind of comments on that. John, if you want to join that call, then that would be great. If you're interested, I can give you the details. It'll be early in the morning for West Coast. If that's where you are. But in any case,
I'm West Coast time. But yeah, sure. I mean, I love propagating these kinds of communities. You know, I find myself in interesting pockets of interesting peoples, and I like to see those peoples grow. So like, this is totally my jam. I'd love to participate, and you know, like maybe Ori would too. I don't know. Road mapping is hard. That's like the long and short of it, right? Because it's like, where do you take it? And it is a community effort. So like, it is everyone.
Yeah, I
You
think
have to build that community and make it. So
yeah,
like,
I think it's also like apart from I mean there's a long term roadmap and then there's the short term thing and stuff you iterate on, right? So even in terms of roadmap, it doesn't have to be some elaborate, giving everybody a notebook every day. It can start with, making it easier for people to start making contributions, and then the short term things of getting more data sets in and how people can do that. It's with the contributing side of things, making it easier to know how to do it. That just kind of gets people started on that bit, and then like you mentioned, just fostering that environment where people can ask questions and collaborate when they can. Just kind of takes it away from there, and then there's Twitter or whatever where you kind of do your hot night or whatever, and that kind of gets some people in a lot more. So
Well, so I think I totally agree. Like that should be. I mean, we should probably be emphasizing it more. Actually, is like there is still a lot of groundwork to be done in the code and also in the kind of the collaboration model of how we're kind of doing these things. There has been some progress recently. There's been some, with some work with introducing the CI that John's been chipping in on, and others, and Eric, and I think we're kind of like feeling our way through it a little bit. But that is one of the things that will facilitate. That's like one of the building blocks for having the kind of high base level hygiene of the project in place, and then other ones, as you said, are kind of good documentation and good documentation that kind of introduces people to the things that they need to know. And I mean, on that note, John, did you want to hear about Sphinx, or are we running late?
I mean, I'm not running late. I got time, but maybe you guys.
East Coast cruise.
nobody's. I don't know. I'm always worried when I can't hear people running in and. But go ahead, John.
Yeah, okay. I'll do like 5 minutes max, and then we can go from there. Share screen.
Yeah, so the context of this is like I was asking, you guys are talking about Sphinx Gallery, and it was something I wasn't quite like, I had never heard of it, so I was like, what's that? And yeah, that's what we're gonna get a quick little demo of. This is in that collective roadmap that John Griffiths was talking about earlier, where it's like there's this thing, Sphinx Gallery, and it would be nice to incorporate into EEG notebooks, but it's not documented in a GitHub issue yet. That's the pain of not organizing. It takes time to organize.
True. And it's I think we're kind of somewhat there with the basic integration. I did pull up some tabs specifically for this, but then I opened a bunch of other ones. So
I did the same thing. I got too many tabs.
So I'm just gonna. Can you see my browser right now?
Yeah.
Yeah. Activity Watch.
Eric's project.
Right. So I thought I could kind of show you two things. I could show you the one that we have and show you the one that's in M&E, which is one of the ones that we base stuff on. It's not the only one, but so essentially, so this is specifically Sphinx Gallery rather than Sphinx per se. But Sphinx it's what do you say, like a website building tool, but specifically focuses around code, documentation websites, and particularly documentation websites that have code in. I guess that's a reasonable summary of Sphinx, and it's Python oriented. So what the standard kind of structure is you have your repo, and then within your repo you have the main. Typically, you have like the main repo name, so which is this is where all the main code is, where you import things. This is the package basically, and then these other things at the top level. The two other key things at the top level are the docs folder and the examples folder. And something that's interesting here, I don't really know why this is the case, but this is the convention, is that the examples aren't in the doc folder, but the examples are part of the documentation. I don't know why that's a convention. Maybe there's a good reason for it, but that's how it is. So if you just look in the doc folder, you've got a bunch of stuff that's so the key thing is the make file, really. And if you're just running this on the command line, you just do make HTML or make install, and the make file it interprets some like your command line arguments basically, and it has. So like this is what make install does, for example, which is how you actually push to GH pages. So it cleans, then it clones, and then it does some organization stuff. It builds the documentation, and then it goes into the builder, and then it pushes basically the HTML the contents of the build that's in this HTML folder in build. So when you run make HTML with Sphinx, then it'll generate a folder called build, and inside build there'll be a folder called HTML, and inside there will be your source that you want to render, your HTML source. And so when you want to host the site on GH pages, the thing you want to actually push to GH pages is the contents of the HTML folder. So this make install command here, this builds the documentation and does the push to GH pages. So basically, like when you do make install, it'll give you your updated documentation on the website. And so what we had for so I'll kind of touch quickly to the CI, which is also relevant here, is, I'll go back up a sec. This is actually a recent addition, but this I'm showing this as an example of that command. So here we go. So this CI process that's like specified by this file, sets up the operating system, installs the library, and then this is the Sphinx Gallery bit. Just go into the folder, as I said before, it's called doc from the top level, and then run make install. And as I said, make install builds the HTML and then pushes to GH pages. So this is how, well, this specifically, this is how I'm generating the documentation at the moment, is just running this command locally. But we want to put it into the CI so that, I mean, for kind of obvious reasons. But and one of the reasons for that is what I was talking about earlier, is like part of the rationale behind the way that these projects are kind of leaning on documentation as trying to kind of integrate it into the core code development process more, because it's good like project hygiene. It means that everything gets documented along the way, and with the CI, it means that, obviously when things break, then because you know immediately. But it also, it just kind of like, it ties the docs in with the core development in quite a kind of integrated way, which is a good feature from the point of view of the project development hygiene and the things we were talking about earlier on. So another thing. So the other thing that I was talking about, we've got the doc folder, and then we've got the examples folder, and the contents of this is Python files, but they have restructured text in comments. So that's basically how Sphinx Gallery works. Is it you write Python scripts that have code in that do things that you want to do, but they also have documentation in, but the documentation is in the comments. And the reason for that is that it means that you can treat them as scripts, but you can also treat them as docs, right? Because they give you both of those. So here's an example. So you can see some of the RST parts of this in the comments in this file is the header there, and then these code blocks that are indicated by the big line, and then the underscore for the title of the blocks, and then we have some tags here that tell the process some things when it's pulling stuff together. But you have to follow these rules. So one of the things that can be a bit of a gotcha when you're working with Sphinx Gallery is not quite getting your RST right in these comment blocks, for example. It's not hard. It's not that hard, but it's a thing that you can get wrong. But so you just kind of block your text sections with your code, with your text, with your code, etc. And then these will appear. So if we now look at the actual page that's built from this, as I said, everything's pushed to GH pages, so it renders on here. And then and this is the website that's generated by this Sphinx library. It looks like Read the Docs because I used the Read the Docs theme because I wanted Read the Docs, but I Read the Docs looking documentation, but I also didn't want there to be ads on it. So I just used the Sphinx Read the Docs theme, and I also wanted to do things like CI, and so on. So that's also like Read the Docs isn't, well, it kind of does that in a way, but not in. I think it was just an extra thing that I thought it'd be better not to actually use Read the Docs. just to make it look like we are. So this was what I was showing you just now. And then you can see, here was the text block. Then we had the code block. Then we had the text block. Then we had the code block. And it knows here, right? So let's say load data, then some text, and then this little code block here. So it was, here we go, load data, some text, then the code here. So that's how this Python script becomes this web page. And I mean, another nice thing about the web pages when they're built is that, well, they kind of look nice, but they also have these little galleries, which are kind of cool. And this is a distinctive feature of these pages. So this is the gallery at the moment. So these are all the built examples. And then these are all located at different locations in the documentation. But yeah, you get a little thumbnail, you get a little tagline, and then when you actually go in, then you get more information. Then another thing that you get, and this was actually the initial motivation for doing this, is it'll give you links to download the code, and particularly it'll give you a link to download a Python script and a link to download a notebook. So one of the things that I was pointing out to people is we called this project EEG Notebooks a while back when Dano was refactoring Muse LSL, and we took all the experiment stuff out of there and just made Muse LSL for like solely a streaming library. And at that point, we were like, okay, we can do all this stuff in Jupyter Notebooks. That's great. So that's why EEG Notebooks got called EEG Notebooks. But a few years down the line, in fact, it's not a great idea to be doing everything in Jupyter Notebooks, because then you're diffing Jupyter Notebooks all the time. And that's just not like the right way to be building code. So that's like another of the, and as I said, that was actually the initial main motivation for using Sphinx Gallery, in addition to just their kind of a slick way of building documentation, is that, so now what we have is we have Jupyter Notebooks. Like if you click on this, you get a Jupyter Notebook that runs fine and does all of the stuff that you can see on this page, but it's auto built from a Python script that has RST in, and then those are kind of composed to give you the Jupyter Notebook or just the Python script. So it's still EEG Notebooks in the sense that you can still get notebooks to run things, but we're not using notebooks as source anymore like we were doing before. And maybe at some point it warrants a rename, but I don't want to be thinking about that right now. So like kind of quickly then, if we look at the same thing for MNE, and as you'd imagine, theirs is a lot there's a lot more going on in MNE than in ours, but you can see the general structure is the same. I mean, it's because I copied theirs, but I copied a few. This is one of them. You see that we've got doc, we've got examples, and we've got the main library package there, right? And in the doc folder, so they have more things, and well, actually, in the
John, I have to go read stories.
Okay.
I'll take care.
Yeah. See you, Morgan. Yeah. Okay. So it's like final thing is they're doing the CI slightly differently in MNE. They're using Circle CI, and I mean they are doing some GitHub workflow stuff, but I'm not sure exactly. It wasn't so easy to kind of figure out exactly what they were doing, but the MNE website is a nice slick website that actually this is built from Sphinx Gallery, and so like the examples page, here we go. This is a huge Sphinx Gallery. So all of the stuff in MNE is all built in the way that I just described, and you get it ultimately like when you have lots of stuff, you have these lovely galleries with thumbnails that are nicely structured.
Yeah, that's a cool demo. Thanks for walking me through the whole Sphinx build process.
Good, good.
It looks like it scales too. So eventually, I mean, as the base grows, then there can be more stuff. So that's a good one.
Yeah.
Are there any plans to document the actual like source itself? So, for example, I know there is some documentation on the CLI, but like even like